Welcome to the Mastering Cassandra video course by Pact Publishing. In this course, we will quickly master the basics to start building our own web-based application with Cassandra. My name is C.Y. Khan. I've been designing and developing large-scale web applications for more than 15 years. I love many software technologies, such as Java, JavaScript, Cassandra, big data, service-oriented architecture, mobile applications, and so on. I'm the author of two other e-learning courses, Cassandra Administration and Rapid Cassandra, and the book Cassandra Data Modeling and Analysis, also published by Pact Publishing. This is the very first video. Here you'll have an overview of this course. We're going to take a look at the structure of this course as a whole and the topics included in each section. This course is divided into 10 sections. Section 1, Introducing Java Web Development. It gives general background knowledge of using Java to develop web applications, including web and persistence frameworks. It also highlights the high-level design of the demo application to be developed over the course, called Cassandra Web Trader. Next, we'll set up and configure our development environment, which covers the installation of the Java Development Kit, the Integrated Development Environment, the very large Spring Framework family, the configuration of Apache Tomcat, and Maven. In Section 3, we'll start designing the demo application by going through the process of collecting user requirements, the logical design of the modules and functions, the data model in Cassandra, the Java class model, and the screen layout design one by one. To build the demo app faster and easier, we need to get familiar with the Spring Framework and its subprojects, for example, the Spring Core Framework, Spring MVC, Spring Security, Spring Data Cassandra, and Spring Integration. We'll learn the necessary Spring components while we're developing the demo application. Next, we'll dive deep into Spring Data Cassandra, which is not very comprehensively documented. In Section 5, we'll build the Cassandra data model, as well as the persistence layer using Spring Data. In Section 6, we'll turn to the business and presentation layers. Moreover, we'll enable Cassandra Web Trader as a responsive web application by using a well-known JavaScript framework, Bootstrap. Now we come to Section 7. We'll internationalize the application, build the stock watch list, retrieve stock data, render technical charts, and allow members to register. Section 8 continues where Section 7 has left off. We'll develop the remaining functions, such as member login, trading signals, email alert, and user authorization. In Section 9, we'll complete the development part and prepare the application ready for production deployment. To get the most out of this course, you should have some basic knowledge of the Java programming language, administration of a Cassandra database, and some Linux commands. I hope you enjoy this journey. We now know the course structure and its pace. We also listed out the preferred knowledge and skills to experience the course most effectively. Next, we'll take a look at web application technologies. Welcome to the first section of the Mastering Cassandra video course, Introducing Java Web Development. In this section, we'll take a look at the fundamentals of Java web application development. The topics include web application technologies, Java web frameworks, and data persistence. Last but not least, we'll touch base with the simple web application that we'll build over the course. Welcome to the second video of this section, Web Application Technologies. We'll start from the ground up and have a general overview of the anatomy of a web application. Then, we'll quickly review the popular web technologies, and finally, we'll highlight a few trending web technologies and their features. First, let's revisit the basic web application model. On the web, the application operates in a client-server model, in which usually a web browser being the client interacting with the web server at the other end. The client and server communicate to each other based on the request-response model using the Hypertext Transfer Protocol, HTTP. The client initiates its request over HTTP to the server, which returns the response over HTTP in turn. This pair of request and response completes one communication cycle, so that both the client and the server will forget what happened between them. Then the client may communicate to other servers, and the server may respond to other clients. This is why HTTP is called a stateless protocol. However, in a more complex situation, such as a dynamic web page, the client needs to communicate with the server in many request-response cycles. It requires that the server has a way to recognize who the client is and what has been done for it. HTTP can't natively support this kind of stateful communication. Therefore, a technique called session is devised to address this shortcoming. A simplified explanation of how a session works is that when presenting a dynamic web page, the server sends the current state data to the client in the form of a cookie. The client then saves the cookie in memory or on disk. With each successive request, the client sends the cookie back to the server, and the server uses the data to remember the state of the web application for that particular client and generate an appropriate response in return. Based on the client-server model of a web application, there are many technological choices. On the client side, the fundamental technologies are HTML, CSS, and JavaScript. They usually work hand in hand to compose an interactive web page that is run on a client browser. On the server side, it's much more complicated. The most commonly used technologies are Java Servlet and JSP, ASP on Microsoft.NET, PHP, Ruby on Rails, and Python, respectively. Now it's time to have a glimpse of the trends in the current web application development landscape. Modern web applications are often characterized in one or more of the following ways. Responsive web applications target to address the cross-browser compatibility problem with the advent of mobile phones. They are device agnostic, such that they can adapt their layouts to the device on which they are run. A technique known as mobile-first design is encouraged to make the layout design responsive. The core technologies employed are CSS3, jQuery, Bootstrap, and so on. Another emerging application is single-page web applications. They're characterized by loading the HTML, CSS, and JavaScript on the client side with a single load. All operations are done on that single page, and no other pages are involved. The resources, for instance images, are dynamically loaded and added to the page in response to various events. AngularJS is a full-featured single-page application framework. The last to be introduced is real-time web applications. They deliver responses to events in a measurable and acceptable time period. They leverage asynchronous and bidirectional communication between the client and the server to achieve such responsiveness. WebSocket is the core technology that provides such features over a single TCP connection. To conclude this video, we illustrated the generic web application architecture and some contemporary web technologies. In the next video, we'll have a look at Java Web Frameworks, the commonly used multi-layered application architecture, and the popular Java Web Frameworks will be introduced. Welcome to the third video of this section. In the last video, we looked at the web application technologies. In this video, we'll focus on understanding the multi-layered application architecture. Then, the feature-rich Java Enterprise Edition will be introduced. Also, many popular Java web frameworks will be covered. A multi-layered application architecture is a general software architecture that uses many logical layers for allocating different responsibilities of a software application. Although there are different ways to allocate the layers, the most common one involves 3 layers. On the top, it's the presentation layer, serving as the user interface to interact with users. It doesn't contain any business logic, as those services are provided by the underneath business layer. One layer down is the business layer. It provides core functionality of the system and encapsulates the business logic, such that the presentation layer can focus on managing the interactions with the application users. At the bottom is the persistence layer. It's responsible for communicating with the data sources, to retrieve and save data, by exposing generic programming interfaces for components in the business layer to consume. We'll touch on that a bit more in the next section. Java Enterprise Edition, or Java EE in short, is the standard in community-driven enterprise software. Basically, it provides a set of API specifications that are the building blocks of any web application. It standardizes and reduces the complexity of enterprise application development. Moreover, it defines a multi-tiered architecture that separates the functionality of an enterprise application into distinct tiers, which is compatible to the multi-layered application architecture mentioned earlier. However, for the sake of developing a web application, we don't need to know the whole family of Java EE components. Since Java EE 7, a trimmed down subset called Web Profile was created particularly for web applications. We now look into the details of the multi-tiered architecture. We start from the top tier. It's the client tier, typically composed of web pages running on client browsers, such that application clients can make requests to the Java EE server. Then the web tier. It handles interaction between the client and the business tier, which is to be introduced next. It controls the screen flow and maintains user session data. It can also generate dynamic content in various formats to the client, such as HTML, PDF, XLS, and so on. The third is the business tier. It provides the business logic for an application. In standard Java EE, the business logic is encapsulated in the form of Enterprise Java Bean, EJB. Both the web tier and the business tier run inside the Java EE server. On the ground level is the Enterprise Information System tier, or EIS tier. It consists of data sources that can be a database, an ERP system, or even a legacy mainframe. So Java EE is a 4-tier application architecture. Java EE is a good paradigm for developing web application in Java. However, it does come with its own pros and cons. The major problem is, to make a Java EE compliant application, we usually require writing a massive amount of boilerplate and redundant code to interact directly with different Java EE components. In addition, the applications that we're building often don't require all the features that Java EE provides. Therefore, the open source community evolved to build frameworks to address this major problem for faster and easier development. Frameworks can alleviate the overhead associated with common activities performed in application development and strongly promote code reuse. Frameworks can exist in every tier. Specifically for web frameworks, Spring MVC, JSF2, and Struts2 are the most common ones. We'll use Spring MVC in this course to develop the web application. In my opinion, it's by far the most effective Java web application framework. Next, we'll have a quick tour of data persistence. Welcome to the 4th video of the Mastering Cassandra video course. In the last video, we had a quick review of Java web frameworks. Now we'll talk about data persistence. In this video, we'll learn about what a persistence layer is. There are also a number of Java persistence mechanisms, which will be briefly introduced. And we'll explain the data access object pattern to wrap up this section. First, let's define what persistence is. It's whenever a software object is able to live independently of an application. Simply put, it means saving data in an underlying data store. Database, file, and LDAP are the most typical persistence stores. So a persistence layer is a nitty-gritty component in the multi-layered architecture to provide coarse-grained programming interface, to isolate the complexities and implementation details of the persistence stores from the upper service layer. In Java EE, the persistence layer usually consists of the following components: Java Database Connectivity, JDBC, Java Persistence API, JPA, Java Transaction API, JTA, and Java EE Connector Architecture, JCA. Java being an object-oriented programming language, it requires a so-called Object Relational Mapping, or ORM in short, to work with relational databases. That means ORM is a way to transform a Java object into an entity in a relational database, and vice versa. To actually implement the persistence layer, the Java community offers a number of choices. First, JDBC. It's the oldest initiative to provide data persistence functions for Java. It uses SQL statements to perform the rudimentary create, read, update, and delete operations on a relational database. Second, JPA is the standard ORM and persistence management interface for Java EE. It provides a standard Java persistence query language, JPQL, to manage the CRUD operations and allows pluggable persistence provider. Third, Hibernate. It's an open source ORM solution supporting object-based modeling and provides a generic query language known as Hibernate Query Language HQL. Finally, Ibatis. It doesn't use the ORM approach. Instead, it encourages the direct use of SQL through the so-called SQL mapping mechanism, but avoids the complexities of JDBC. Finally, iBodice. When we talk about data persistence, a core Java EE design pattern called Data Access Object can't be left behind. DAO is used to abstract and encapsulate all access to the data source by exposing a much simpler programming interface. It completely hides the low-level implementation details of the data source from the above service layer. Hence, it acts as an adapter between the service layer and the data source, so that it can minimize the changes on the service layer arisen from the changes in the data source, and vice versa, leading to a more decoupled application. In summary, we described the purposes and functions of the persistence layer in the multi-layered application architecture, and the DAO pattern. Next, we'll have a look at the web application that we're going to develop, Cassandra Web Trader. Welcome to the final video of this section, Cassandra Web Trader. In the last video, we had a quick look at data persistence. And now we're going to talk about our sample web application to be designed and developed in this course. We'll develop a running real-world web application using Java and Cassandra. The application is called Cassandra Web Trader, which is a stock quote web application providing stock scanning service for trading signals based on technical analysis methods. We're going to introduce what the web application is about and its high-level architecture and the components to be involved. And we'll plan how to actually develop Cassandra Web Trader. Before we look into the details, here's a disclaimer that Cassandra Web Trader is only for educational purposes, and you're not assumed to be following such a program to trade financial instruments. Alright, Cassandra Web Trader is a membership web portal that serves as a stock screener to scan for trading signals on a number of stocks based on a certain set of technical analysis screening criteria. The market data will be obtained from Yahoo Finance, which provides free of charge end-of-day stock quote data. As a membership web portal, it provides functions such as member sign-up, log in and log out, stock watch list, email alert of trading signals, and stock charts. Cassandra Web Trader will follow the multi-tiered architecture as shown in the diagram. Starting from the bottom, the data will be stored in a Cassandra database. Then, one level up, Spring Data for Cassandra will be used to handle the DAO to manage the persistence layer. For the business tier, we'll use a number of Spring Framework modules for various core functionalities. For example, Spring Framework will be the backbone of the application to compose the business logic and glue everything up. Spring Web MVC will be the Java Web Framework to manage and control the screen flow. Spring Security will be used to provide member authentication and authorization functions. The view technology selected is JSP and JSTL. For working with browsers, of course, we'll use HTML5 and CSS3 respectively. On the top is the client tier, running in a web browser. We'll use a very popular JavaScript framework, Bootstrap, to make Cassandra Web Trader a responsive application. Also, we'll leverage the powerful graphic features of another JavaScript framework, D3.js, to draw stock charts. Let's talk about how to develop the application. Of course, we'll make it a web application that requires a browser to render the user interface. The membership account data, historical market data, trading signals, and alert history will be stored in a Cassandra database. Apache Tomcat will be used as the web container to host the application. The programming language is Java. So we'll use an Eclipse-based IDE called Spring Tool Suite to manage the project. It's well configured for faster and easier development using the Spring framework. The web framework will be the most popular Spring Web MVC. The application framework is Spring. For package dependency management, we'll use Apache Maven. And we'll use a Java driver for Cassandra from DataStax to access Cassandra objects in the Java programs. Finally, we'll use a well-known open-source library called TALib to help with calculations on technical analysis trading signals. In this section, we've built a solid foundation for the development of a Java web application. To recap, we started from the generic web application architecture and then some popular web technologies. We then introduced the multi-layered architecture, the Java EE family, and several Java web frameworks. Then we went into the persistence layer and explained the data access object pattern. Finally, we briefly described the functions and architecture of the sample web application Cassandra WebTrader that we're going to build, and the development approach for the course. Next, we'll go to Section 2 of the course, where you'll be setting up your toolbox. Welcome to the second section of the Mastering Cassandra video course. In the last section, we learned about the application architecture of a Java web application. In this section, we'll set up our toolbox. We'll set up our development environment, including Java Development Kit, Apache Maven, Eclipse IDE, the Spring Framework, and Apache Tomcat. Okay, let's begin the first video in this section, Java Development Kit. In this video, we're going to choose, download, and install the appropriate version of the Java Development Kit. Then we'll configure the environment variables and verify the installation. This is the online documentation of Cassandra 2.2 provided by DataStax. As shown here, the recommended Java version is 8. So we'll follow DataStax's recommendation and install Java Development Kit version 8. The operating system of the development environment for this course is Ubuntu 14.04 64-bit desktop. Here we'll go ahead to configure Ubuntu to install 64-bit JDK. Open a terminal. First, install some dependent software packages. Type in sudo apt-get install python-software.properties. Press enter. Done. Then we need to add the repository of Oracle JDK installer to the Aptitude Package Manager. Type in sudo add-apt-repository ppa:/webupd8team/java. Press enter. OK. Then refresh the repositories of apt. Type in sudo apt-get update. Press enter. Wait for a while. OK, great. Now we'll install the Oracle Java installer by typing in sudo apt-get install Oracle Java 8 installer. Press enter. Press Y to continue. When finished, we type in Java version and press enter. It prompts the Java version is 1.8 64-bit. So it's installed successfully. Excellent. We now go to configure the environment variables. Type in vi:/.profile. Add the 3 export statements to the bottom of the file. Save and quit. Type in source:/.profile. Well, we can also test if the environment variables are set correctly. Type in javac version. So far, we're good. Finally, let's check the Java home variable by typing echo string Java home. Press enter. Everything's all right. We've installed and configured JDK correctly. Good job. Next, we'll proceed to install Apache Maven. Welcome to the second video of this section, Apache Maven. In the last video, we installed JDK. In this video, we're going to look at a brief introduction of Apache Maven. Then we'll install Maven into our development environment. After that, we'll configure and verify if the installation is correct. Maven is also an active project under Apache Software Foundation. Here is its website. Basically, Maven is a software project management and comprehension tool for Java. It can automatically take care of the complex Java package dependencies and manage any conflicts that happen. It also streamlines the Java development cycle by a bunch of Maven plugins. More on this in later sections. For our development environment, we use version 3.3.3. Click on Download here. Scroll down a bit and download the binary version in tarzip format. Click on Apache Maven 3.3.3 bin.tar.gz. Switch to the terminal. Change the directory to Downloads. Extract the downloaded archive. Then move the whole extracted directory to /opt. List the destination directory to verify the move operation. Great. We'll now configure the environment variables. Type in vi:/.profile. Add the last 4 export statements to the bottom. Note that we added the Maven opts variable here to direct Maven to use a larger heap size. This is necessary when we'll be using Maven to compile and package a large Java project. Save and exit. Type in source ~/.profile to make the environment variables effective. Type in nvn --version. Great, it returns some messages saying Apache Maven 3.3.3 and the Java version being used is 1.8. So we can run Maven in the terminal properly. In this video, we introduced and installed Apache Maven. Next, we'll install the central Java development environment, Eclipse IDE. Welcome to the third video of this section, Eclipse IDE. In the last video, we installed Apache Maven. In this video, we'll have a look at a special version of Eclipse IDE, particularly for Java projects using the Spring framework. We'll install that IDE as our fundamental development environment, and we'll configure and verify if the installation is correct. In the Java community, Eclipse has been one of the most popular integrated development environments for quite a long time. Although it's very flexible, it may be a daunting task to install each and every plugin from scratch, especially for a Java project based on the Spring framework. Hence, the Spring community created a convenient IDE based on Eclipse with all the necessary plugins, called Spring Tool Suite, or STS for short. We can download STS from Spring's website as shown here. Click on See All Versions under the Spring Tool Suite. We see that STS provides support for Windows, Mac OS, and Linux. For us, we'll download the 64-bit Linux version. When the download finishes, switch to the terminal. Change directory to Downloads, extract the download archive. Similar to Maven, we'll move the extracted directory to /opt. Then we add the environment variable in .profile, scroll to the bottom of the file, add the last two export statements, save and exit. Type in source ~/.profile to make the environment settings effective. Now we launch STS for the first time. Type in STS. The STS splash dialog pops up. After a while, the STS IDE shows up. As you can see, it's very similar to the Eclipse IDE, so if you've been using Eclipse, you should have no difficulties using STS as well. Well done! We selected Spring Tool Suite as our primary development environment and installed it on Ubuntu. Next, we'll use STS to build a simple web application using Spring Framework. Welcome to the fourth video of this section, Spring Framework. In the last video, we installed Spring Tool Suite. In this video, we'll first have a high-level overview of the very large family of Spring Framework. Then we'll use Spring Tool Suite to create a very simple web application with Spring. We'll also explain the structure of a Spring project configured in Maven. First, we'll go to the Spring project's website, as shown in the browser. You see there's quite a number of Spring projects providing different functionalities. Over this course, we'll use some of them, but not all. For example, Spring Boot, Spring Framework, Spring Security, Spring MVC, and so on. Now let's go into Spring Boot. Spring Boot aims at building up and running a Spring application as quickly as possible. We'll use it to build a very naive web application in STS. Let's turn back to STS. On the menu bar, select File, New, Spring Starter Project. It provides a number of Spring project templates for us to configure and creates the skeleton Java project. Leaving all the inputs as provided, scroll down to the bottom and select Web Only. Click on Finish. Since this is the first time we'll run Spring Starter Project, it'll take some time to download all the required dependencies and plugins. When the download is complete, a project called Demo is created in the Package Explorer on the left. Expand the Demo project. It shows that the Demo project is already Maven managed. Double-click on pom.xml. Click on pom.xml in the bottom tab. Here we see that the parent of this project is a Spring Boot starter. Look down a bit in the Dependencies section. As we had checked the Web option earlier, the Spring Boot Starter Web is included in the project. It's time to write some code. Click on Demo in the Package Explorer. Then right-click, select New, and then Package. Give the package name demo.controller. Click on Finish. Then right-click on demo.controller package, select New, and then Class. Name it Hello Spring. Click on Finish. Right above the public class statement, add the annotations @REST-controller and @enable auto configuration. Accept the suggested imports. Inside the class definition, create a function called home without parameters and returning a string. Inside the function, type in return hello spring. Add another annotation @requestMapping, parentheses, quotation, slash, quotation, close parentheses, on top of the function declaration statement. We can test run the project now. Right-click on the demo project icon, select Run As, and then Spring Boot App. A bunch of messages pop up in the console. Now open up a web browser. In the address box, type in localhost 8080. The web page shows Hello Spring. This is the string returned by the Hello Spring class. Let's revisit the console again. Even though we haven't had any web server installed, we can still run the web application. The magic here is achieved by Spring Boot. It includes an embedded Tomcat instance. If you have some prior experience in Java web development, you know you might need a lot more effort to install and set up the web container or application server beforehand to run a web application, let alone the correct packaging and deployment of the web application. But now with Spring Boot, everything is pretty straightforward. Next, we'll have a look at how to install and configure Apache Tomcat. Welcome to the 5th video of Section 2, Apache Tomcat. In the last video, we used Spring Framework to build a simple web application. In this video, we'll have an introduction of Apache Tomcat. Then we're going to download and install Tomcat into our development environment. Finally, we'll configure Tomcat's graphical management interface to wrap up Section 2. Apache Tomcat is a web container primarily for running a web application composed of Java servlets and JSPs. Because Tomcat just serves web artifacts, it is not a comprehensive application server. The release has been advanced to version 8.0, and we'll download and install this in our demo environment. Here, click on tar.gz under the Core section to download the software package. When the download completes, switch back to the terminal. Change the directory to Downloads. Extract the downloaded archive. Move the extracted directory to /opt as well. List the destination directory. Okay, the files are there. We may try to start up Tomcat by running the shell script startup.sh in the bin directory. The script echoed Tomcat started. Now let's switch to the web browser and type in localhost 8080. This time we didn't see the Hello Spring message. Instead, we see the Tomcat welcome page. Hence, Tomcat is started properly. Turn back to the terminal and run shutdown.sh script in the bin directory. It shuts down the Tomcat process. Change directory to conf. We'll create a Tomcat user with rights to manage web application inside Tomcat. Type in vi tomcat-users.xml. Scroll down to the bottom of the file. Just above the last non-empty line, we add the manager-GUI role and a new user named Spring with the password Spring. Its role, of course, is manager-GUI as enabled above. Let's restart Tomcat again. When we click on the Manage App button, a login box pops up. Enter Spring as username and Spring as password. The graphical management interface is shown here. It details each deployed artifact and allows us to start, stop, restart, and undeploy any one of them. In later sections, we'll deploy the developed application to run in Tomcat. In this section, we installed and configured our development. We installed JDK, Apache Maven, Spring Tool Suite, and Apache Tomcat. We also touched on the Spring Framework and its large number of subprojects, and even used them to build a very simple web application. In Section 3, we're going to start the design of our demo application, Cassandra Web Trader. See you there. Welcome to the 3rd section of the Mastering Cassandra video course. In the previous section, we set up our development environment. In this section, we'll design the Cassandra Web Trader using a top-down system analysis and design approach. We're going to start the design from the user requirements. Then we'll analyze the requirements, design the functions, and group them into packages. Then we'll design the data model and the class model respectively. Finally, we'll make the screen prototypes to complete the high-level Cassandra Web Trader. First, let's take a look at the user requirements in this video. In this video, we're going to take a look at the list of user requirements that will be developed. We'll also describe the different user roles of the web application. Also, we'll cover the non-functional requirements. We divide the user requirements into a few categories. First, general function. This includes the landing page and the error page, which will be used to display readable error messages to the user. The second category is for the members of Cassandra Web Trader. The application will provide registration function for potential members. Also, it'll include login, logout, and forgot password. A member can also get the stock chart and inquire the trading signal history. Here we come to the third category, technical analysis. There's only one, but a very important core function, trading signal scanner. The last category is the admin functions. It includes maintenance of watch list and inquiry of members. Cassandra Web Trader allows 3 different user roles to access different functions. The first one is guest. That is an anonymous user who can access the unauthenticated pages. For example, the landing page, login page, and member registration page. The next is member. It's a registered user who can access the unauthenticated and member protected pages. For example, the chart and trading signal history page, log out page, and forgot password page. The third user role is admin. Admin is a super user who has all the absolute authorities to administer and manage the website. For example, the inquiry of member information page and watchlist maintenance page. Aside from the functional requirements, we also need to take into account the non-functional requirements. Since Cassandra Web Trader is an application using technical analysis methods, it definitely requires stock quote data. We'll use free-of-charge end-of-day historical stock quote data from Yahoo Finance. We'll make Cassandra Web Trader a fully responsive web application, which is compatible with a desktop browser and a mobile browser. Lastly, we'll make the application production-ready for production deployment using Spring Boot. Now we've drafted out the major functions that Cassandra Web Trader would provide. Next, we'll design the modules and functions. Welcome to the second video of this section, Modules and Functions. In the last video, we listed out the major functions of the application. In this video, we'll design the logical architecture of the application. We'll then look at modular package design and the URLs of the web application functions. As we decided to use Java to develop Cassandra Web Trader, we'll adopt a layered architecture to logically separate the application into different layers. The core layers, as mentioned in Section 1, are the presentation layer, the business layer, and the persistence layer. Starting from the presentation layer, we'll adopt the MVC design pattern, Java server pages, and JavaScript to compose the views of the application. The next layer is the business layer. It encapsulates the user functions as services, for example, trading signal scanner, and so on. The persistence layer is composed of POJO domain classes, such as member and trading signal. We'll apply DAO design pattern on the persistence layer. The complexities of accessing Cassandra database will be confined in the DAO classes. With the layered architecture, we can now consider the packaging of the Java classes based on major responsibilities. To make types easier to find and use, to avoid naming conflicts, and to control access, we bundle groups of related classes and interfaces into packages. The application root package is com.CassandraWebTrader, which contains the main application class and the Java configuration class. For MVC controllers, we'll group all of them together into com.CassandraWebTrader.controller package. Similarly, we'll put all POJO domain classes into com.CassandraWebTrader.domain package. Also, com.CassandraWebTrader.service package will contain all business service classes. And com.CassandraWebTrader.repository package groups all DAO classes. There will be some other miscellaneous classes that are necessary to support the application. They'll be placed in the com.CassandraWebTrader.util package. With the allocation of those packages in place, we can summarize the packages in the high-level package diagram shown here. So basically, we'll create 6 packages to group most of the classes and interfaces together to get started. There may be other supplementary packages when necessary over the course. Now it's time to think about the access URLs for the MVC views. The landing page will be accessed via /home path. The error page will be shown at /error path. Then the URLs for the member functions are shown here. The member functions cover registration, login and logout, forgot password, chart, and trading signal history. They're all put under the /member path prefix. The chart and trading signal function will be accessed at /member/trading signal path. At last, the access links for the admin functions are listed out. All of them are placed under /admin path prefix. The views or functions with the /member and /admin path prefixes can be easily protected. So, we made a high-level logical design of the application. Next, we'll have a look at the data model. Welcome to the third video of this section on data model. So far, we touched on the functions and logical design of Cassandra WebTrader. In this video, we'll design the Cassandra data model. We'll think about the data to be persisted in the database. And we'll write SQL scripts to create the keyspace and tables. As we use Java to develop an application to interact with a Cassandra database, we need to represent the data entities, or persistence entities, in both parts. In Cassandra, we use tables to store the data of member, stock quote, watch list, and trading signal. So their counterparts in Java will be the domain classes, member, stock quote, watch list, trading signal, respectively. We'll talk about Cassandra tables in this video and cover the Java domain classes in the next. We need to create a keyspace in Cassandra to host all tables. The keyspace is named CWT. For the development purpose, we're not going to create a production-ready keyspace. So the replication strategy for the time being is simple strategy, and the replication factor is set to 1 only. We need to store member information in Cassandra. The table is called member. We won't store extensive member information, just the username, email address, full name of the member, the current password, and a flag to indicate if the subscription status is active. Cassandra WebTrader is a technical analysis application, and so it's obvious that we need to store historical stock quotes for trading signal scanning. We'll store the symbol, time of the stock quote, the open, high, low, and close prices, and the transacted volume in a table called stock quote. We also want to have control on the stocks to be included for trading signal scanning. A table called watch list will be created to hold a list of stocks. The table simply stores a watch list code and the stock symbols to be scanned. The last table to be created is trading signal. Whenever Cassandra WebTrader finds a trading signal on a stock, the exact date and time, the price, and the relevant trading signal name will be stored. We now have the initial data model. In this video, we designed the data model. Next, we'll design the Java classes. Welcome to the fourth video of this section, Class Model. In the last video, we came up with a data model for Cassandra. In this video, we'll touch on the topics of Java class naming convention, the application architecture, and the main Java classes. It's a good practice to exercise a set of rules on the naming of Java classes, interfaces, and so on. Using a naming convention can reduce the effort needed to read and understand the source code. Basically, we'll use different suffixes to indicate the roles and responsibilities of a class if it's part of a design pattern. We'll use an access link as a part of a name for MVC classes. Take login as an example. The access link as we defined in previous video is /login. We then name the MVC controller for login as login controller and the JSP as login.jsp respectively. For a domain class, we'll simply use the same underlying Cassandra table name. For a business service, the name will be composed of the functional description and a service suffix. The DAO class will be named by the domain class being supported with a repository suffix. For other Java classes, we'll use meaningful names to describe them. Up till now, it's good for us to have an overview of the structure of the Java packages and classes. The JSPs will be put under a folder in the application. All MVC controllers will be under com.cassandrawebtrader.controller package. All services will be under com.cassandrawebtrader.service package. All domain classes will be under com.cassandrawebtrader.domain package. All DAO will be under com.cassandrawebtrader.repository package. And there will be miscellaneous classes and interfaces. They'll be put into respective packages appropriately. Here we list out the names of the Java classes. We'll abbreviate Cassandra WebTrader as CWT whenever appropriate. In the application root package, there will be the main application class, CWT application. Inside the com.cassandrawebtrader.domain package, we'll create 4 classes to represent their corresponding tables in the Cassandra database. Similarly, the com.cassandrawebtrader.repository package contains all repository interfaces. The com.cassandrawebtrader.controller package includes all the MVC controller classes, as shown. The com.cassandrawebtrader.service package contains all business services. The com.cassandrawebtrader.util package will have a common util class, which will provide common utility functions such as string-to-date conversion and so on. Up till now, we mostly did design on the back-end server side. In the next video, we'll have a quick tour of the screen prototypes of the website to complete our initial application design. Welcome to the last video of this section, Screen Design. In the previous sections, we focused on the back-end server design. In this video, we'll make some wireframe screen prototypes of the application. We'll use a very good prototyping tool called Pencil to build the wireframe screens. Pencil is built for the purpose of providing a free and open-source GUI prototyping tool that people can easily install and use to create mockups in popular desktop platforms. We won't go through the installation of the Pencil software. The details can be found at its website. We installed Pencil in our Ubuntu development environment. Pencil has collections of shapes and stencils included by default. We simply drag and drop the shapes and UI components from the left pane to the drawing area on the right. Now we're going to go through the prototypes of some major screens of Cassandra WebTrader one by one. The first, of course, is the landing page. Let's have a look at the structure of the screen. We'll have a logo and a menu bar at the top of the screen. Below that is the main content area for various user functions. On the bottom is a footer that'll be used to display supplementary information. A generic screen will be created for showing severe errors. It'll provide consistency whenever we come across them. Next, the screens for member functions. Here's the member registration screen. A potential member will input her brief information and the preferred password here. The login screen is simply requiring a registered member to enter username and password. Cassandra WebTrader also provides the Forgot Password function, which is used for the member to retrieve their password. Chart is the main screen that a member usually interacts with. A member can input a stock symbol, and Cassandra WebTrader will then retrieve the historical stock prices to plot the candlestick chart. Trading Signal History is a screen for a member to inquire the past trading signals of a particular stock. The remaining screens are for administrators' use only. The first is the Member Information Inquiry screen. The admin will also be able to maintain a watch list on the stock of interest so that Cassandra WebTrader can collect market data from Yahoo Finance and process them in the background based on a defined schedule. To summarize what we've covered in Section 3, we used a top-down approach to analyze and design the application architecture. We began from the user requirements and the user roles, and then proceeded to the logical application design and Java package design by applying design patterns. We then designed the initial data model for the Cassandra database and the Java classes. Finally, we produced wireframe prototypes by using the open-source tool to illustrate the user interface. We'll dig into the Spring Framework in the next section, Understanding Spring Framework. Welcome to the 4th section of the Mastering Cassandra video course. In the last section, we made a high-level design of the application. In this section, we'll learn about the core components of the popular Spring Framework. We're going to start from the Spring Core Framework and understand what dependency injection is about. Then we'll get familiar with Spring Web MVC and the closely related Spring Security frameworks. Then we'll tap into the basics of Spring Data Cassandra, which lets Java very easily access a Cassandra database. Finally, we'll talk about Spring integration. First, let's take a look at the Spring Core Framework. In this video, we're going to introduce the Spring Core Framework. We'll also learn about dependency injection to make programs loosely coupled. In parallel, we'll build an example program to explain the use of Java annotations, thus avoiding the tedious work with XML. We can go to Spring's official site at spring.io. Under the umbrella of Spring, there are in fact many sub-projects covering different aspects of Java development. But for the time being, we'll focus on the most fundamental Spring core. At its origin, Spring was made as an alternative way to tackle the old notorious problems of enterprise Java beans. The core concept is to adopt dependency injection to come up with a loosely coupled and easy-to-maintain programming model for enterprise applications. We're going to build a sample application to facilitate our understanding of dependency injection. We'll build a non-Spring version first. Create a new Spring Starter project. Name it Chapter 41 and change the group to com.Cassandra WebTrader and the artifact to Chapter 41. This wizard basically helps us build up the Maven configuration file. Click on Finish. Then create a new class named Client1. Click on Finish. Client1 is a POJO class, and we'll add a public method called SaySomething without any parameters. This method just prints a message to the console and does nothing else. Then we refactor Client1 by right-clicking and selecting on Refactor and then Extract Interface. Enter the interface name as Client. Select the SaySomething method, click on OK. Now Client1 is refactored with an interface called Client. Create another class called Server. Click on Finish. We add a private attribute called Client of the client interface and instantiate it immediately. Then we create a public method, callClient, which simply calls the client's SaySomething method. So when callClient method is called, the SaySomething method of the client attribute will be called to print out a message to the console. We go back to the application's main class, Chapter 41 application. Here you'll see the Spring Boot application annotation. This helps us to manage all the tedious configurations and lets us concentrate on writing the program logic. We need not touch on it for the moment. In the main method, create and instantiate a server local variable of the server class. Then we call the callClient method of the server variable. Alright, let's run the program. In the console, the log shows that it's a Spring Boot application, with a Spring application context created, and the message, "This is Client1," is printed. So, this is the non-Spring version. Well, let's just modify the code to make it Spring-based then. Go back to the main method. Change the first line to get the Spring application context to the CTX variable. At the end of the method, we close the application context. Remark the server line. Declare the server variable again, but this time we get the server instance from the Spring application context. Basically, Spring maintains a pool of objects called beans in its application context, so that we can retrieve whichever object we want from it. The first parameter is the bean ID of the server instance, and the second is the type of the class. Next, we need to modify the Client1 and server classes. Go back to Client1. We add an @component annotation here. @component indicates that Client1 is a component to be turned into a Spring bean. It tells Spring to create an instance of Client1 in the application context. Similarly, we add @component annotation to the server class. Then we remark the private line, and we just declare the client attribute without immediate instantiation. We add another annotation, @resource, to instruct Spring to inject a bean of the client interface type to this client variable. It makes a huge difference in program design. The server class doesn't tightly couple with the concrete implementation of the Client1 class anymore. Instead, it just refers to the interface client, which is a contract that the server uses to communicate with whatever classes that are abided by this contract. Apart from the @resource injection approach, there are other choices, such as @autowired, @inject, and so on. Please refer to the reference link for further information. Let's run the program again and see the magic. The console is the same, but now we have a Spring-based version instead. That's a wrap for this video. Next we'll learn about how to use Spring to develop web application. Welcome to the second video of Section 4, Spring Web MVC. In the last video, we touched on the basics of dependency injection. In this video, we'll touch upon developing the web application using Spring Web MVC. We'll also explain the Spring project setup. Finally, we'll build a simple web application to illustrate the minimum basics of the framework. Spring Web MVC provides a solid infrastructure and MVC model for developing web applications. It supports different view technologies, for example JSP, Velocity, FreeMarker, Tiles, and so on. It also provides comprehensive support for common web application requirements, including I18N, locale, and theming. The diagram here can explain the magic of Spring Web MVC. The central component is the front controller, which dispatches requests to subsequent controllers and offers a functionality that facilitates web application development. The implementation of the front controller is called the dispatcher servlet, which, as its name suggests, dispatches requests to handlers with configurable mappings, view resolution, locale, time zone, theme resolution, and other functions. Okay, let's create another Spring project called Chapter 42. Open pom.xml. We need to add the embedded Tomcat dependency as shown here to make the project executable in a standalone fashion. Create a new class called WebController. Add the @controller annotation to mark it a request handler. Add a logger. We use SLF4J, that is also used by all Spring Framework projects. Add a public method called index, which just writes a log message and returns the name of the view for the view resolver to locate the correct view. Then add the @requestMapping annotation to map the root URL, that is /, to this request handler. What the request mapping here does is to map the root URL to the index.jsp view. We then need to create the view file, index.jsp. First, create a folder for the view file. Click on src/main, right-click, and select New Folder. Type in webapp/web-inf/jsp and click on Finish. Then click on the JSP folder just created, right-click, and select New Other. Select JSP file and click on Next. Give it a name, index.jsp. Click on Finish. Change the content of the file to what is shown on the screen and save it. Okay, we've created the view file. By virtue of Spring Boot, we need not explicitly create an instance of the view resolver. However, we need to specify the configuration settings of the internal view resolver in the application.properties in the src/main/resources folder. Here we use /web-inf/jsp/ as the prefix and .jsp as the suffix to come up with the correct JSP view. Now run the project as a Spring Boot application. In the console, we see that the application context bootstrapped the request mapping of the / path to the web controller class, the index method. We also see that the embedded Tomcat engine has started to listen to port 8080. Spring Boot really helps a lot and streamlines the application development. It also shows that there are some default request mappings created automatically, such as /error. So whenever an exception is thrown, the default white label error page will be shown. Of course, we can customize it whenever necessary. Open the browser, type in localhost 8080 and press the Enter key. Well, it shows the message returned by the web controller class. Behind the scenes, the request to the / path triggered the index method of the web controller class, as we mapped them by the @request mapping annotation. The index method then returned index that was used by the hidden view resolver to form the location of the view file, and Tomcat rendered that JSP file to the browser. Let's shift our guns now and look at Spring Web MVC's counterpart, Spring Security, in the next video. Hello, and welcome to the third video of this section on Spring Security. In the previous video, we looked at Spring MVC. In this video, we'll introduce Spring Security. We'll also explain its setup in a Spring project. And we'll use Spring Security to protect the index.jsp page of the example application that we developed in the last video. Spring Security is best for securing a Spring-based web application. It provides authentication and authorization functionalities. Most of the time, we use it to protect the resources in the presentation layer, but it actually can help secure all layers within an application, including the service layer. In this video, we'll touch on the authentication part only. Create a new project called Chapter 43. Follow the same steps from the last video to make a simple web application. Then open pom.xml and add the Spring Security dependency as shown here. We see that the web controller is the same. Similarly, application.properties is also the same. No changes were made. Run the application. Open the browser and type in localhost 8080 and press the Enter key. This time, a dialog box asking for username and password pops up. Click on Cancel. The white label error page is shown, saying that the response code is 401, meaning we supplied bad credentials. So index.jsp is protected. Switch back to STS. In the console, we see that a security filter chain is created with default URL patterns. Also, Spring Security provides the random default security password. Select the password and copy it. The default username is user, which is preset by Spring Boot. Go back to Firefox and refresh the page. The same dialog box pops up again. This time we enter user as the username and paste the default password to the password field. Well, the index.jsp page is shown successfully as we provided the correct credentials. In this example, we used the Spring Security default configuration to secure all web resources. Indeed, Spring Security offers various configuration annotations and class for fine-grained access control. We'll go deeper into that in the later section. Next, we'll learn about Spring Data Cassandra. Welcome to the fourth video of this section, Spring Data Cassandra. In the last video, we briefly looked at what Spring Security is about. In this video, we'll get familiar with Spring Data Cassandra. We'll learn about its basics and then create a sample Cassandra database. Afterwards, we'll create a Spring-based application accessing the sample database using Spring Data Cassandra. Spring Data Cassandra is actually a sub-project of the much larger Spring Data project, which aims at making data access technologies to be used by Spring-based applications in an easy way. Spring Data Cassandra follows the use of the already familiar interface of Spring Data to communicate with a Cassandra database. Open a terminal and launch CQLSH. Create a keyspace called CWT with the replication setting as shown. Use CWT. Then create a table named Member with fields such as username, email, and password. All of these are text fields. Then insert some test data into the table. OK. Switch back to STS. Create a new Spring project called Chapter 44. Open pom.xml. We need to add the Maven dependencies of Spring Data Cassandra, and the Cassandra database driver, and driver mapping from DataStax. Create a package com.cassandrawebtrader.config. Create a new class called Cassandra Configuration. Then annotate the class with @configuration and @enableCassandra repositories. Modify the class definition to inherit from the abstract Cassandra configuration class. Then we need to create the Cassandra cluster factory bean and Cassandra mapping context beans as shown. In the cluster method, we provide the Cassandra connection properties, such as the host and port of the local Cassandra instance. Finally, we override the getKeyspaceName method to specify the keyspace, that is CWT, to be connected. We've coded the database connection. Now we create a POJO class, member, to represent the entities in the member Cassandra table. We mirror the data definition in this Java class. The username, email, and password fields are of string type. Username is annotated with @primaryKeyColumn, while other fields with @column. Then generate the getters and setters, the toString, and the equals methods. In order to make use of Spring Data Cassandra functions, we need to create a repository interface for the member class to extend from Cassandra repository. Cassandra repository interface provides several default data access functions, for example, find all. However, we also want to create a custom method to retrieve a member record from the member table. It's exactly done by the findByUsername method. The method should return an iterable object holding the returned records. We see that the @query annotation allows us to provide a CQL statement that will be used by the findByUsername method. Note that the parameter of the CQL statement is a placeholder remarked by $0. Now it's time to create a server class to test the program. The server class is a Spring bean that has a private attribute of the member repository type, annotated with @AutoWired. @AutoWired instructs Spring to wire up the member repository bean automatically. We then create a public method called printMembers, which just calls the findAll method of the member repository to return the records of all members. Remember that we haven't written even one single line of code for the findAll method. It's automatically done by Spring Data Cassandra. What follows is a for loop to print out the member information to the log console. Lastly, we turn back to the Chapter 44 application class to get the server bean from the application context. We then call its printMembers method and close the application. Before we can test run the program, we need to do one more thing. Open application.properties. Type in liquibase.enabled equals false. It turns off the database version control function provided by Spring Data Cassandra. We don't need that for the time being. Alright, we can now run the program. In the console, we see that the program connects to the CWT keyspace in the sample Cassandra database. The records of the member table are returned accordingly. Next, we'll go through another very useful Spring component called Spring Integration. Welcome to the last video of this section, Spring Integration. In the last video, we touched on Spring Data Cassandra. In this video, we're going to look at Spring Integration. We'll describe its basic mechanism and the sample integration flow to be demonstrated. We'll also write a simple program to implement the integration flow. Spring Integration was created to extend the Spring programming model to support the well-known Enterprise Integration Patterns, EIP. It's a simple yet lightweight messaging framework for Spring-based applications and supports integration with external systems through declarative adapters. By following the EIP approach of architecting enterprise application, we can develop maintainable, testable code while keeping a simple, flexible programming model. To demonstrate the basic functionality of Spring integration, we're going to implement the sample integration flow shown here. We'll create a Spring-based application called Chapter 45 application that will send a text message to the input channel. The message will then arrive at the trading alert service that simply uses the received text payload to format an email message. The new email message will be sent to the output channel and finally arrive at the email service. For a simple demonstration purpose, the email service only prints out the received email message payload to the log console instead of really sending out an email. Let's now write the code to implement the sample flow. Create a new project called Chapter 45. Open pom.xml. Add the Spring integration dependency as shown. Create a new package, com.cassandra-webtrader.service. Then create a new class named Trading Alert Service. Annotate the class with @service, which tells Spring to create the instance as a service. Add a public method called Trading Signal Alert with a string parameter. Annotate the method with @serviceActivator and configure the correct input and output channels for the method. @serviceActivator annotation helps to handle the incoming message payload, extract, and put the text as the method parameter. The method does nothing but return to the output channel a string composed of the method parameter that is received from the input channel. We now code the second class service, Email Service. Annotate the class with @component. Create a public method named sendEmail with a string parameter. The @serviceActivator annotation does more or less the same thing as the case of Trading Alert Service, but this time only an input channel is configured. The method simply simulates an email message and prints the email message content to the log console. We need to configure Spring integration using Java-config, thus avoiding the use of the cumbersome XML. Create a new package named com.cassandra-webtrader.config. Then create a new class called Chapter 45 config. Annotate the class with @configuration to tell Spring that it is a configuration. @integration component scan to scan the integration components in the specified packages. And @enable integration to turn on Spring integration functionality. We create two beans, which are the input channel and output channel respectively for the integration flow. Note that both channels are of direct channel type. Finally, we modify the main method of the Chapter 45 application class to kickstart the flow. We retrieve the input channel bean that was configured in Chapter 45 config and compose a message by utilizing the message builder. It's then the easy task, calling the send method of the input channel to send out the message. Okay, the coding stuff is done. When we run the program, we see in the console log that Spring bootstrapped the integration components in the background. The log also shows that the dummy email service was triggered, as indicated by these highlighted lines. In summary, we learned about the Spring core framework and the basic dependency injection. We then went through a few sample Spring projects, illustrating the functionality of Spring Web MVC, Spring Security, Spring Data Cassandra, and Spring integration, respectively. We now should grasp the basic knowledge of the Spring framework. In the next section, we'll dive deep into Spring Data Cassandra. Welcome to the Mastering Cassandra video course. In the last section, we looked at some major Spring components that we'll be using to program the application. In Section 5, we'll dive deep into the Cassandra module of Spring Data Framework. We're going to understand its functionalities and relationship with Spring Data. Then we'll learn about the various data access methods offered by Spring Data Cassandra through coding a number of example programs. The methods include JDBC style, Query Builder style, and POJO style, respectively. We'll then leverage on dependency injection to configure the program to connect to a Cassandra database. Lastly, we'll demonstrate how to use the administration template, which is seldom mentioned elsewhere. First, let's have a peek at the core concepts. In this video, we're going to introduce the basic knowledge of Spring Data Cassandra module. We'll then learn to properly set up a Maven project to enable it. Also, we need to be aware of the best practices recommended by the Spring Data Cassandra project team. Spring Data Cassandra follows the overall objective of Spring Data. Its goal is to make the implementation of a data access layer simpler and easier by significantly reducing the effort spent on too much boilerplate code. It primarily provides a number of templates, builders, and repositories to achieve its goal. The repositories are the most powerful feature provided. It's an abstraction capable of working with the domain class to manage data access. The core interface is the CRUD depository. It provides sophisticated create, read, update, and delete functionality for the domain class being managed. The CRUD repository interface provides trivial operations such as save, find one, find all, count, delete, exists, so on and so forth. In addition to this, it provides support for pagination access. We can use STS to write a Spring Data-enabled application quickly. Switch back to STS. Create a new Spring Starter project called Chapter 51. We don't need to add any dependencies here, and so simply click on Finish. We add the Maven dependencies manually. Open pom.xml. Add the Spring Data Cassandra dependency. As Spring Data Cassandra requires DataStax' Java driver and mapping, we add them accordingly. Open Chapter 51 application class. Add two private static variables to represent the cluster and session to be connected. First, we modify the Spring application to return a configurable application context to the CTX variable. Then use cluster.builder to add the IP address of the cluster. In our example, it's the local cluster. Then we can assign the session connected to the CWT keyspace as shown. It's also a good practice to close the application context when finishing the program. Run the project as a Spring Boot application. In the console, we see that the program successfully connected to the local Cassandra cluster. Thus, we can access the Cassandra cluster in a Java program. We'll explore the functionality provided by Spring Data Cassandra in the videos that follow. Spring Data Cassandra is an open source project, and its source code repository is hosted in GitHub. We can always find the latest project status and information in here. It's also worthwhile digging into the source code to better understand the inner workings of it. Scrolling down a bit, we see the Best Practices section. We should visit here from time to time to get the latest update. Particularly the considerations shown here deserve our attention. First, when creating a template, we should wire in a single session per keyspace, because a session is thread safe. Therefore, only one session per keyspace per application context is allowed. Even though we can submit native CQL commands and statements in Spring Data Cassandra, it can't be stressed enough that we must not issue the use keyspace command explicitly. Also, Spring Data Cassandra works closely with DataStax' Java driver, which specifically handles all failover and retry logic behind the scenes. We don't need to take care of them in our applications. Finally, be sure to include all hosts spanning across all data centers when getting the cluster connection. Next, we'll look at how to use JDBC style to access a Cassandra database. Welcome to the second video of this section, Query Methods. In the previous video, we started to learn the basics of Spring Data Cassandra. In this video, we'll tap into the various data access methods provided by Spring Data Cassandra. We'll start from the JDBC style and then the Query Builder style. And we'll use CQL template class to demonstrate how to use them. Before we can use Spring Data Cassandra, we need to prepare the Cassandra data model. Open a terminal. Run CQLSH. Use the CWT keyspace. Then create a table person with the 3 fields as shown here. Alright, let's switch back to STS. Create a new project called Chapter 52 by copying the Chapter 51 project. Rename Chapter 51 application to Chapter 52 application. We'll add our code in here. Spring Data Cassandra supports the old school JDBC style, meaning that we can write low-level data access calls the same way as we do with other JDBC compliant databases. Particularly for Cassandra, the template class provided by Spring Data is called CQL template. So we create a local CQL template variable, COPS, for executing the CQL statements. We may write native CQL to manipulate the data. For example, we want to create a record into the person table with an insert statement, and call the execute method of CQL template to run the insert statement. We may also use a helper class known as Query Builder to facilitate the makeup of data manipulation statements. Query Builder provides methods just like the spoken language that are very easy to comprehend. The great advantage is that we don't need to learn the CQL syntax and write native CQL statements to access data as shown in the previous example. Here we create an insert object called example2 to insert another record into the table. Similarly, we execute the insert object with CQL template's execute method. CQL template also supports parameter binding in the native CQL statements so that we can prepare them for efficient repeated calls. We provide the parameters with the bind method and run the execute method the same way. Okay, we've inserted 3 records into the person table. We may verify the insert operations by writing a select query. The query method of the CQL template class will return a result set if records are found. Write a while loop to iterate through the result set and print out the record details in the log. Okay, we've done the coding part. Now we move on to test run the project. Run the project as a Spring Boot application. It did the job successfully, and the 3 inserted records can be returned by the select query. So, we may use both JDBC style and Query Builder style to access data in a Cassandra cluster, but they do involve much code. Next, we'll look at another data access method, Cassandra template. Welcome to the third video in this section on Cassandra templates. In the last video, we learned about how to use CQL template, which is pretty much a JDBC way of accessing data in Cassandra. In this video, we'll learn about how to use POJO with Spring Data Cassandra. We'll introduce a number of Java annotations that makes the use of POJO very easy. And we'll write an example program using the core Cassandra template and Cassandra operations. Create a new project called Chapter 53 by copying the Chapter 52 project. Then create a new package, com.cassandrawebtrader.domain. Click on Finish. To illustrate the support of POJO style, we must create a POJO first. Create a new domain class in the package just created. Name it Person. Click on Finish. First, let's annotate the class with @table to tell Spring Data that this class maps to the person table in Cassandra. Then add 3 fields, an ID field of string type, a name field of string type, and an age field of integer type. Among these fields, the ID field is the primary key, and so we annotate the field with @primaryKey. Then add the constructors, toString, and so on. Open the Chapter 53 application class. Remove the logic of the last video, except the portion of code involving cluster and session. Spring Data Cassandra provides support for Pojo by Cassandra Template and Cassandra Operations. Cassandra Operations is an interface of operations for interacting with Cassandra. These operations are used by the repository implementation, but can also be used directly when desired. The Cassandra Template class is a convenient API for all Cassandra operations using Pojo with their Spring Data Cassandra mapping information. We'll insert a new person record into the person table through the insert method of the Cassandra Operations interface. Note that we simply create a Pojo instance and pass it to the insert method, which is much more intuitive than the methods introduced in the last video. Cassandra Operations also provides support for Query Builder. We may use Query Builder to construct a select query to get back the person just created. Now we submit the select query and the domain class type to the select method of the Cassandra Operations interface. It should return a person instance representing the row in the person table. Finally, we dump the details of the returned person instance in the log. Run the project as a Spring Boot application. We see that the log shows the details of the person record we inserted beforehand. So, Pojo can be used with Cassandra Template and Cassandra Operations to make our code more readable. Next, we'll introduce how to configure Spring Data using Java-Config and the powerful Cassandra repository interface. Welcome to the fourth video in this section, Configuration. In the previous video, we saw how Cassandra Template worked with domain Pojos. In this video, we'll get familiar with the base class Abstract Cassandra Configuration for configuration using Java-Config. We'll introduce the Cassandra Cluster Factory Bean for configuring a Cassandra cluster. Lastly, we'll make use of the powerful Cassandra Repository Template interface to greatly reduce the amount of boilerplate code. Create a new project called Chapter 54 by copying the Chapter 53 project. Create a new class called Cassandra Config in a new package, com.cassandrawebtrader.config. Click on Finish. Add @configuration to make Spring aware of this class as a bean. Then add @enable Cassandra repositories annotation to enable the Java-Config features. Specify com.cassandrawebtrader as the base package to scan for Cassandra repository classes. Change the getKeyspaceName method to return our keyspace, CWT. Now we can use the Cassandra Cluster Factory Bean to configure our Cassandra cluster. Cassandra Cluster Factory Bean is a convenient factory for configuring a Cassandra cluster. We create a method called cluster to return such a bean, and annotate the method with @bean such that Spring will be aware of this class as a bean. We may then set the contact points. For our case, it's the local Cassandra instance, so we input 127.0.0.1, and the port is 9042. Create another bean, Cassandra Mapping, to enable metadata mapping. That's all for the configuration. Create an interface called Person Repository in a new package, com.cassandrawebtrader.repository. Click on Finish. Extend the interface from Cassandra Repository for the domain class Person as shown. Cassandra Repository provides a handful of convenient default implementations of saving, counting, deleting, and finding data such that we don't need to write any code. Add a new method called findOne to retrieve a row of person by a given ID of string type. Here we use @query annotation to provide the CQL statement. So whenever we call this findOne method, Spring Data Cassandra will use the provided CQL statement to find the row and map it to a person domain entity. We may now make an example program to illustrate how to use the repository. Open Chapter 54 application class. Remove the logic for the last video. As we enabled Cassandra repository in the Cassandra config class, the person repository interface will be found by the Spring application context and be instantiated as a bean. We may get the person repository bean from the application context. We choose a default implementation, for example, the save method, to persist a person instance. The ID is 987-654-3210. The name is Mary, and the age is 20. Note that we haven't written any code for the save method. Then we use our find1 method to retrieve the person just saved. Display the details of the retrieved person in the log. Run the project as a Spring Boot application. The person details are shown here. So we see that Cassandra repository is really something great, and is able to reduce a great deal of boilerplate code required in other data access styles for the same operation. It's indeed my preferred way of accessing Cassandra in Java applications. Next, we'll go through another template dedicated for Cassandra table administration. Welcome to the last video in the 5th section on administration template. In the last video, we looked at using Java-Config to configure Spring Data Cassandra. In this video, we're going to look at the operations for managing a Cassandra table. We'll describe how to use Cassandra admin template and Cassandra admin operations to create a table in a Java program. We'll also write another example to retrieve and show the metadata of that table. Apart from the CQL template and Cassandra template, Spring Data Cassandra also provides a template particularly for managing tables, called Cassandra admin template. Basically, Cassandra admin template is extended from Cassandra template. It implements the table management methods of the Cassandra admin operations interface. Similarly, Cassandra admin operations is an interface extended from Cassandra operations. It specifies that the implementing class has to provide concrete implementation of the alter table, create table, drop table, and replace table methods. So from the names of those methods, we can easily know that Cassandra admin operations can be used to create and drop a table, modify the table structure, and replace an existing table with a new table. Now let's write some code to experiment with its use. First, create a new project called Chapter 55 by copying the Chapter 54 project. Open cassandraconfig.java. We need to create a Cassandra admin operations bean, since Spring Data Cassandra doesn't automatically instantiate one for us. The constructor requires the session and the converter that converts a Java object to a row and vice versa. Both the session and converter can be obtained by the abstract Cassandra configuration class. Then we create a new domain class called event. We use @table to annotate the POJO to map to a Cassandra table, also called event. The POJO has 3 fields, event ID, name, and event time, respectively. Event ID will be the primary key of the table, and so we use @primaryKeyColumn annotation to specify the corresponding field ID and the primary key details. For the remaining 2 fields, we use @column to map the corresponding field names in the event table. Create the constructors, toString, etc. accordingly. Okay, that's all for the POJO. Then go to Chapter 55 application class. Remove the logic of the last video. We then get the Cassandra admin operations bean from the application context. Remember that we created a bean in Cassandra configuration? We then create a local variable of CQL identifier class called TableName to map to the target table, event. Then we're ready to create the Cassandra table through the annotated POJO. We use the createTable method of Cassandra admin operations. The first parameter is ifNotExists. We assign it as true so as to create the event table if it doesn't exist. Then the table name, the POJO class, and the last parameter is the table options. For example, the compression and compaction settings. We simply give it null. With that, we can create a table without writing even a single line of CQL statement. For verification purposes, we retrieve and show the metadata of the table just created. We use the getTableMetadata method provided by Cassandra admin options class. We specify the key space and the table name, and want the method to return the metadata information as a string and display that string in the log. Well, we can run the project as a Spring Boot application. See? The metadata of the event table is shown in the log here. Basically, it's exactly what the describe table event command in CQLSH shows. Let's verify it. Open a terminal, run CQLSH. Use the CWT keyspace, type in describe table event. Besides a slight formatting difference, it shows the same create table statement as that in the log. It means that we can fully manage a Cassandra table in Java by Cassandra admin template and Cassandra admin options without using CQL. To sum up, we learned about the details of Spring Data Cassandra. We mastered with ample examples the various data access methods provided by Spring Data Cassandra, such as the low-level JDBC style, POJO style, and repository style. We also grasped how to use Java-config to configure a Cassandra cluster so that we don't need to manipulate the tedious XML configuration files. Finally, we demonstrated how table administration tasks could be done by Cassandra admin template and Cassandra admin operations. In the next section, we'll start building Cassandra WebTrader. Welcome to the 6th section of the Mastering Cassandra video course. Till now, we should be familiar with Spring Data Cassandra to access data in Cassandra. In this section, we'll start developing the Cassandra WebTrader application. We're going to create and configure the Cassandra WebTrader project with necessary dependencies. Then, we'll build the web user interfaces using Spring annotations and taglibs. We'll use Bootstrap 3 to beautify those user interfaces and make the application responsive. Then we'll use d3.js and its decedent Tekken.js to make nice-looking stock charts. Lastly, we'll develop an email service that can be used to send out email trading signal alerts. First, let's create the Cassandra WebTrader web application project. In this video, we're going to use Spring Boot to simplify the web application project setup. We'll then mock up the web user interfaces with reference to the screen prototypes designed in the earlier sections. Also, we'll use WebMVC configuration to customize error pages instead of using the defaults. Let's start then. Launch STS. Create a new Spring Boot project called CWT. Name the group as com.Cassandra WebTrader, artifact as CWT, and select Web in the dependencies. Click on Finish. Now we need to add the embedded Tomcat and the JSTL dependencies in pom.xml. Then, under src/main, create a new folder for holding JSPs. Input webapp/web-inf/JSP as the folder name. Click on Finish. Then select com.Cassandra WebTrader. Create a new class. Change the package to com.CassandраWebTrader.controller. Input Home Controller as the name. Click on Finish. Home Controller is the MVC controller to serve the request at /home. So, we annotate the class with @controller and @requestMapping for /home. We then create a public method showHomepage to return the view name home. We annotate this method with @requestMapping as well. We should make the home page similar to the screen prototype we made earlier. Create a new JSP file called home.jsp in the JSP folder just created. Click on Finish. Modify the title to Cassandra WebTrader. Add a div for logo, another div for menu, the third div for H1 Cassandra WebTrader, the fourth div for description of the content, and a final one for footer. In order to let the default view name resolver to locate the correct JSP, we need to add spring.view.prefix and spring.view.suffix, as shown in application.properties file under src/main/resources. This is the simplest Spring MVC web application. Okay, let's run the project as a Spring Boot application. Type in localhost 8080/home in the address bar. See? It works, right? Excellent. Though it doesn't look very attractive now, we'll improve the look and feel later on. If we change the URL to localhost 8080, this error page is the default provided by Spring. It's okay, but we need to customize the error pages to use our own design. So, let's create a class called webconfig in the package com.cassandrawebtrader.config. Click on Finish. Webconfig is basically a Java-config file that we created for Spring Web MVC, and therefore we annotate it with @configuration. We can customize Spring to map each error to different error pages. We'll add a bean by a method to return an anonymous embedded servlet container customizer. We'll override the customize method here to map the 3 HTTP error status codes to their respective error pages. For example, an unauthorized HTTP request gives 401 status code, which will map to 401.html file, so on and so forth. Now we create 401.html in src/main/resources/static folder. Click on Finish. Amend the error page at will. Change the title, add the page heading, then add a user-friendly description. Copy and paste 401.html to create 404.html and 500.html. Amend them as well. All right. Restart the application. Go to localhost 8080 again. This time, Spring shows us our customized error page. Great! That brings us to the end of this video. Next, we'll create input forms and introduce the relevant annotations. Welcome to the second video of this section on forms and annotations. In the previous video, we started to use Spring Web MVC to build our application. In this video, we'll apply the data transfer object pattern to make our MVC application interactive. We'll introduce the tag libs provided by Spring to handle forms. And we'll come up with a foundation controller to handle GET and POST requests typically found in an HTML form. We'll build an input form for a new member to register. The screen prototype looks like this. Create a new class called registerForm in a new package com.cassandrawebtrader.dto. Click on Finish. This class is just a POJO, passing data between a controller and a view. Hence, it's the model part of the MVC pattern. Create 5 fields for username, email, full name, password, and the active flag. Then generate toString, the getters and setters, and constructors. Create a new controller named registerController. Add @controller and @requestMapping to /member. Create a method called showRegisterForm to handle the GET request at /register. A parameter named model is used to pass the data between the view and the controller. We need to create registerForm as the form-backed object and add it as the attribute to the view register. Now create the register.jsp. Add the tag libs for JSTL, Spring tags, and Spring form tags before the doctype tag. Add a page header, please sign up. Add a div for the form tag. Note that the model attribute is registerForm, passed from the controller. Add a div for the username input. Add a form label with path equal to username. Then add a form input with path equal to username2. Then add a description under the form input. Repeat these steps for email, full name, and the password. Finally, add a button for the submission of the form, and add another one for clearing the input fields. Okay, cool. Now reset the application. Go to localhost 8080/member/register. The register form shows up. When we click on the register button, a 405 error is found. It's because we haven't coded the POST request method, so let's do it now. Go back to registerController. Create a public method called postRegisterForm as the POST request handler. The first parameter of the function is registerForm, annotated by @modelAttribute. It tells Spring to map the form attribute of the same name to registerForm. First, let's check the binding result to see if there's been any error. If it's true, just go back to the form. If not, we just log the content of registerForm to the console and go back to home. Go to localhost 8080/member/register. Type in some dummy data. Click on Register. Now the application went back to home. Let's check the console log. See, the content of register form is shown here, so the post request is handled. We've built a basic form handling controller. That's great! Next, we'll introduce Bootstrap to make our application beautiful and responsive. Welcome to the third video of this section on responsive web application with Bootstrap. Previously, we touched on the usage of the forms and annotations in Spring Web MVC. In this video, we'll introduce what Bootstrap is about. We'll then go through how to install and set up Bootstrap in our project. And we'll use Bootstrap to beautify our web user interface. Bootstrap is a very popular framework for developing responsive web applications. Its website is at getbootstrap.com. This is the landing page. Really neat, right? Let's click on Download Bootstrap. We have 3 download options. For the time being, we're only interested in using it, and so just click on the Download Bootstrap button. Save it to a folder. When download is complete, extract the Bootstrap archive and copy the JS, fonts, and CSS folder to our project. Put them under src/main/resources/static folder. We should have a folder structure like this. So basically, Bootstrap is just a collection of CSS and JavaScript files with some glyph icons in a font format. npm.js is basically for node.js, a JavaScript backend engine. We don't need it, so let's delete it from the project. As mentioned on its website, Bootstrap depends on jQuery. Therefore, we need to install jQuery into our project as well. Go to jQuery.com, click on Download, then click on Download the compressed production jQuery link. Select all the contents here and copy them. Return to our project. Create a new file in the src/main/resources/static/js folder. Paste the contents into this file and save it. Go back to Bootstrap website. Move on to Basic Template in Getting Started. We'll use this minimal Bootstrap document to set up our project. Open home.jsp. Copy the code in the head section of the basic template and paste it into here. Fix the title. Change the CSS path to an absolute one. Then copy the JavaScripts in the body section. Paste it here. Change the JavaScript paths to the local absolute paths. Restart the application to see the effect. Go to Home again. See, the fonts are changed. But it still looks a little dull. Let's add some Bootstrap components to make it vivid. Bootstrap provides a handful of examples on its website. All the examples are responsive and mobile first. The secret is the fluid grid system that can gracefully adjust the layout to adapt to different device or viewport sizes. I strongly recommend you read the examples there. Let's find an appropriate example to make up our home page. Go to Examples on the Getting Started page. The navbar example looks good. Click on it. View the page source. Copy the code in the container div. Paste it onto home.jsp. Refresh the home page. Ha, we made it! Looks good, right? We'll use it as our template, enhance and customize it down the road. We changed the project name and title to Cassandra Web Trader. Since the header and footer are more or less the same, we want to create a header.jsp and footer.jsp to avoid a great deal of boilerplate code. Footer.jsp should look like this. Put it under JSP/include, and header.jsp also in JSP/include folder. Then we only need to add includes to blanket the main content area. Apply the same header and footer in register.jsp. Also, add the Bootstrap CSS classes to the form and its controls. Run the application again. See, now register.jsp looks much better. The layout still looks good in this small screen size. We can try others as well. Fantastic! That's a wrap for now. Next, we'll use d3.js to make up a sample stock chart in Cassandra Web Trader. Welcome to the fourth video in this section, Making Charts with D3.js. In the last video, we incorporated Bootstrap to make our application web responsive. In this video, we're going to introduce a very powerful data visualization JavaScript framework called D3.js and its counterpart for financial charts, Tekken.js. We'll learn about how to install and set them up in our project. Of course, we'll make a sample chart. D3 is actually an acronym of Data-Driven Documents. It's a JavaScript library for manipulating the document object model based on data using HTML, SVG, and CSS to provide powerful visualization components using a data-driven approach. We may download D3.js in a zip format, or just go direct to the source code online and then copy and paste to our project. Just like Bootstrap, we put D3.js under JS folder with a name d3.v3.min.js. Great. Another JavaScript library, particularly for financial charts, is called Tekken.js. It's based on D3.js and can be found at bl.ox.org/Andre Dumas. Let's click on Tekken.js Ichimoku Cloud. A sample is shown. Beautiful, right? Scroll down the page a bit, the source code is here. Further down is the sample data.csv being used for the sample chart. Let's make use of this sample chart in our project. Go back to SDS. Create a new controller called Trading Signal Controller. Add the @controller annotation. Create a method named showTradingSignalPage and map it to the /member/tradingsignal path. It only returns to view name that is trading signal. Then we create the tradingsignal.jsp. Remove the default code. Add the includes of header and footer. Make a placeholder div with an ID chart1 for the chart. Then go back to the sample chart page. Copy the styles and save them into a CSS file called ichimoku.css in the CSS folder. Then include this CSS file in header.jsp. And add a menu item to link to Trading Signal. Copy the body section of the sample chart, paste it right after chart1 div like this. Change body to #chart1 here, and add a / to data.csv. Finally, we copy and paste the sample data.csv into your project. Put it in the static folder. Restart the application. Click on Trading Signal. Wow, we have a sample chart here, and hence we integrated D3.js and Bootstrap together. That's it for now. We'll make the chart dynamic in later videos. Next, we'll look at how to set up an email sender in our application. Hi there, and welcome to the final video in this section, Email Setup. In the previous video, we added the charting capability to the application by using D3.js and Tekken.js. In this video, we're going to integrate our app with a mail service provided by Spring Boot. We'll configure a real SMTP server settings and create the mail service component for sending out trading signal alerts. In order to enable our application to send out emails, we need to add the Spring Boot starter email dependency in pom.xml. Save it. Then open application.properties. We intend to put the SMTP server configuration parameters here. We have 4 parameters: spring.mail.host, spring.mail.port, spring.mail.username, and spring.mail.password. Please set yours as per your choice. Create a new service class in com.cassandrawebtrader.service package. It's called Mail Service. Click on Finish. Annotate the class with @service to tell Spring that it's a service. Add a private attribute MailSender that is auto-wired. Here we just use a simple text message that doesn't include attachments. Then add a method to compose and send out the email. Name it SendMailAlert. First, make an email template. Set the email message properties such as to and text. Then make a try-catch block to call mail sender to send the message out. Log the sent out message and any error message if an exception happens. We then create a controller to test the mail function. Name it mail controller. Its request path is /mail. Write a method called sendMail to call the sendMail alert method of a mail service instance. It then redirects back to the home page. Restart the application. Go to localhost 8080/mail. It went back to the home page. Switch back to STS. Check the console log. Here it is. The message was sent out as shown. This is good. In summary, we started from scratch to use Spring Web MVC to build the Cassandra WebTrader web application. We introduced and used a lot of Spring annotations and taglibs. Moreover, we used very popular JavaScript libraries, Bootstrap, D3.js, and Tekken.js to make our application both appealing and feature-rich. Finally, we created a mail sending service, which will be used to send out trading signal alerts in the later videos. In the next section, we'll continue building more functions of Cassandra WebTrader. Welcome to the 7th section of the Mastering Cassandra video course. In the previous section, we quickly built up some fundamental functions for the application, such as charting, web responsiveness, and so on. In this section, we'll continue building the nuts and bolts of our web application. We're going to enhance the functions of Cassandra WebTrader in various aspects. We'll make use of message sources to enable internationalization of the application. We'll also build the watchlist function to provide CRUD functionality to a table in the Cassandra database. Then we'll code a program to collect and decode the historical prices from Yahoo Finance and put it in a scheduler to run. When the stock data is ready, we may build a JSON web service to feed the data to generate stock charts. Lastly, we'll work on the member registration function and see how to use flash messages. First, let's look at internationalization. In this video, we're going to introduce message bundles and locales. We'll then learn how to configure them and internationalize our front-end web pages. Spring includes internationalization, or I-18N supports. It provides an easy way for accessing the resource bundle through the message sources. Open web config. Modify the class to extend from web MVC configure adapter. Copy and paste this message source method. We set the base name of the message property files to simply messages. So the English messages will be in messages_en.properties and so on. Then copy and paste the locale resolver method. Here we set English as the default locale. Then we override the add interceptors method to add the language parameter to indicate locale changes. That's all for web config. Now let's enable internationalization for register.jsp. Open register.jsp. We see that there are many English messages or labels here and there. The task we're going to do is to put all these English messages into the English message file and use Spring tags to retrieve them instead of hardcoding. So let's create a new file named messages_en.properties in the static folder. Here we extract the English messages from register.jsp and replace them with unique keys. Their mapping will be saved in messages_en.properties file. Doing it this way, Spring will know how to retrieve the message and put it into the view. For example, we give a unique key registerform.form.title for please sign up. Put them in the message file. Then replace please sign up here with this code snippet. It tells Spring to get the message of the key registerform.form.title. Make the keys for the remaining messages. Replace all hard-coded messages with the corresponding Spring messages. Now open header.jsp. We modify the menu to offer our application an English version and a Spanish version. As we've set an interceptor for the language parameter, we may just append a language parameter to indicate the locale like this. As I don't know Spanish, I copy the English messages into Google Translate to get the Spanish version. Select all the Spanish version and save it to message_es.properties. Restart the application, go to Home, click on Register, click on Spanish. We have a Spanish version now. Of course, there are still some labels that need to be I18N enabled, but we know how to do it now. Next, we'll look at building a CRUD function for the watch list. Welcome to the second video of this section, Watch List. Till now in this section, we demonstrated how to use internationalization to make our application provide the user interfaces in English or Spanish. In this video, we'll connect our application to the Cassandra database. We'll also learn about how to display the records in a responsive HTML table. And we'll develop typical CRUD functions for watchlist. Before we make the program, we need to create the tables in Cassandra. Launch CQLSH. Run the CQL statements to create the tables. Okay, let's go back to STS. First, we need to add the Maven dependencies. Open pom.xml. Add Spring Data Cassandra, Cassandra driver core, and Cassandra driver mapping as shown. We also add the dependencies for field validation. Save it. Then create a new class named Cassandra config in com.cassandrawebtrader.config package. Annotate it with @configuration and @enable Cassandra repositories. Copy and paste the code into here. These 3 Spring beans are what we saw in previous videos. Now we should be able to connect to Cassandra. Okay, we're going to create the domain class now. Name the class watchlist and put it in com.cassandrawebtrader.domain. Click on Finish. Annotate it with @table to map to the watchlist table. Both watchlist code and symbol make up the composite primary key, so we annotate them like this. Partitioned here means these 2 fields are forming the partition key in the sequence given by the ordinal values. Then a column named active to indicate if the symbol should be watched or not. Generate 2-string constructors and so on. For simplification, here we provided the default watchlist code to be HK001, and the default value for active is Y. Then create the repository interface for watchlist. It's called watchlist repository in com.cassandrawebtrader.repository package. It extends from Cassandra repository. Initially, we'll use the defaults, and so leave it as it is here. Make a DTO called watchlist form for the watchlist controller that is to be created next. It carries watchlist code, symbol, and active with the appropriate validation constraints. Then the bread and butter. Create watchlist controller in the controller package. Give it annotations. Add a private attribute for the watchlist repository and auto-wire it. Then create a getRequest method to render the page. We want to show all records on the page, and hence we call the findAll method of the repository to return all records represented by the watchlist's attribute. We also want to let users add new symbols on the same page, and so we instantiate the watchlist form DTO to back up the form. The attribute name is watchlist form. The view to be rendered is watchlist. It's the part for get requests. Let's move on to create the view before completing the post request method. Create watchlist.jsp. Copy and paste the code from this video's source code. Basically, it uses Bootstrap to compose the input form for the addition of new symbols. Note that the path is suffixed with create. It's followed by a table listing out all the symbols in the watchlist. The Bootstrap CSS are table and table striped. If there's any record, we use a for loop to iterate the records to show the symbol, the active flag, and the links for edit and delete, respectively. Note that the link for edit is suffixed with edit, and the symbol as parameter. For delete, we call a JavaScript function to confirm the action, and if confirmed, a request will be passed to the link suffixed by delete and the corresponding symbol as parameter. The JavaScript snippet for delete confirmation is here. Let's add watchlist to the header menu. Restart the application, refresh home, click on watchlist. The upper section is for adding a new symbol to the watchlist, and underneath is a table showing the sample symbols. Add a test symbol to the input box and click the Add button. An error page is shown, saying that the post request method is not supported. It's true, because we haven't implemented that. So let's do it now. Go back to Watchlist Controller. Create the post method called postWatchlistForm. If the binding result contains error, just go back. If OK, we need to map the DTO to the domain class for saving the new record. Here we'll write a helper class to simplify the code for mapping. Then call the save method of watchlist repository to add the new symbol. Finally, redirect to the same path to refresh the table. We'll create the helper class watchlistMapper in com.cassandrawebtrader.util package and autowire it. The conversion mapping logic from the domain class to the DTO class is simple. Let's also overload the method to convert the DTO class back to the domain class. Mark the class with @component. Then in Watchlist Controller, add a private attribute for the watchlist mapper and autowire it. Test run the application. Add 0000.hk as the new symbol. Click on Add. See, 0000.hk is created. Okay, it's time to complete the edit link as well. It's handled by a getRequest method named editWatchlistPage. The logic is simple. We create another view, watchlistEdit, to offer the input form. We look for and retrieve the record of that particular symbol through the watchlist repository, and then map it to the DTO by a mapper function and pass it to the view. The watchlist repository doesn't provide the findBySymbol method, and so we need to make it. This function is annotated with @query and the CQL statement. Note that the watchlist code is hard-coded to be HK001. Create watchlist-edit.jsp. Copy and paste the code from register.jsp and change it for watchlist. By referring to the postWatchlistForm method, it's very easy to make a similar post request handling method for watchlist-edit.jsp. We add a deleteWatchlistPage method, and the logic is intuitive and no need to explain in detail here. Test run the application. Go back to Firefox, refresh. Click Edit here. Edit Watchlist Page is shown. Modify active to in. Click Save. When we click Delete, a confirmation dialog box pops up. When we click OK, 0000.hk is deleted. It works like a charm. So we have a working CRUD function. That's excellent. Next, we'll look at data feed and scheduling background with Spring Framework. Welcome to the third video of this section, Data Feed and Scheduler. In the previous video, we made the watchlist function. In this video, we'll touch upon how to collect historical stock prices from Yahoo Finance. We'll decode and save the prices into our Cassandra database. And we'll make this process a scheduled job using Spring annotations. We can find most of the historical stock prices at Yahoo Finance. For example, if we want to get Apple's prices, we may click on Historical Prices and the end-of-day prices are there. At the bottom of the page, there's a link for us to download the prices in CSV format. We'll write a service class to make the price retrieval and the related processing automatic. So, the first thing to do is create the domain class. We name the class Quote. Map it to the stock quote table. Nothing special. Then create the repository interface for Quote. Also, no magic here. Now it's the core. Let's create a service class called Yahoo Feed Service in the service package. Annotate it with @service. Add a private quote repository attribute that is auto-wired. Copy and paste the getStock method from the downloaded source. This method uses the URL class to retrieve the Yahoo Finance CSV stream of the specified time period and put it into a buffered reader. Then copy and paste the parseQuote method. It decodes each line of the CSV stream, converts the data type of each column, and creates the corresponding quote POJO. The third one to copy and paste is the getData method. It accepts a symbol and will then check the last date of the stock data in the database by a new method, findLastBySymbol, in the quote repository. This logic can avoid repeatedly downloading the same data again and again. If the symbol is brand new, we'll try to collect the data from January 1, year 2000. It then calls the getStock method with appropriate time period. We need to create the findLastBySymbol method. Turn to Quote Repository Interface, add the method and the query like this. Now we'll create a Spring scheduled job for the collection of the data feed. Name the class Yahoo Feed Job, which is placed in the com.cassandrawebtrader.job package. The class is an @component. To make it a scheduled job, we need to use the @enableScheduling annotation. And we want to put the scheduled job parameters in the scheduler.properties file. Add the auto-wired attributes as shown. Obviously, we need Yahoo Feed Service class. This job will look up the default watch list, HK001, to get a list of stocks to collect data, and so we need the watchlist repository. As we need to access the scheduler.properties file, we use the environment interface to get access to the environment in which the application is running. We then create the scheduler.properties file first. 4 parameters are here. We want the scheduled job to run in a fixed rate of 36 million milliseconds. That's 10 hours. And we want to pause the download by 1000 milliseconds, that is 1 second, between symbols. The default watchlist code, as mentioned, is HK001. The final parameter controls whether the scheduled job will download the data or not. The scheduled job is just a method annotated with @scheduled. The schedule is a fixed delay type with an interval given in the com.cassandrawebtrader.fixedRate parameter. Then the isRun Boolean runtime variable to control the download. If the job is run, the symbols of the default watchlist will be retrieved and be looped through to collect the data. We supplement the findByWatchlist code method in the watchlist repository interface with the query like this. Alright, we should test it now. Change the Run Yahoo Feed Service parameter in the properties file to true to turn on the job. Restart the application. While the application is running, we see that the historical prices are downloaded from the URL displayed here. Thus, our database has some data now. Sweet! Next, we'll build JSON web service to provide data for stock charts made by d3.js and tekken.js. Join me there. Welcome to the 4th video of this section, JSON and stock chart. In the previous video, we set up a scheduler to collect and parse stock data feed from Yahoo Finance. In this video, we'll look at how to build a RESTful web service to provide historical prices in JSON format. We'll build a form to input stock symbol and render the stock chart using tekken.js. We'll learn about how to integrate the RESTful web service with tekken.js behind the scenes. When we look at tradingsignal.jsp that we built earlier, we see that the data for the stock chart is hard-coded in data.csv. The JavaScript code here reads data.csv and converts each column into the respective data type. The columns include date, volume, open, high, low, and close. So what we're going to do is build a RESTful web service to supply the data in JSON for D3 and change the column names to map to ours. First, let's create a DTO for the data. Name it OHLC. It's a typical POJO with the attributes of the same column names required by the JavaScript counterpart. We then create a controller named DataController, which is annotated with @RESTController, meaning that this controller will send the response with response body. We map the URL to /data and produce the response in JSON. The quote repository is auto-wired to retrieve the historical prices of a symbol. And the core is the symbol feed method that returns a collection of OHLC DTOs. We don't want to display all the historical data on the chart, and so we limit the retrieval to the last 250 only. This is implemented by the findLastInBySymbol method of the quote repository. Then we write a helper method, convertQuotes, to map the list of quote objects to a list of OHLC DTOs, which is returned to the view. Now we create the findLastInBySymbol method. Hover the mouse on the name and right-click, select Create the Method. Change int to integer. Add @query to specify the CQL statement. Okay, great. Next comes the convertQuotes method. It just loops through the list of quote objects and adds each converted OHLC instance into the list. Next, we create the view. Create a new JSP file called cloud. We'll just copy and paste the code from watchlist-edit.jsp and modify it. Change the title to chart. Remove the panel title. Change the path to /member/chart and the model attribute to chart. Remove the form group of active. Rename the submit button to show chart. Logically, we need to create the controller for that form. Call it chart controller. The get request method is trivial. It just creates the form-backed object chart and puts it to the form attribute. And return the view name cloud. The chart DTO is simple. We'll skip the explanation here. One thing we left out is the post request method. As all the logic is done in the JavaScript, we just pass the chart attribute to the view that renders the chart. That view is cloudchart.jsp. We copy and paste tradingsignal.jsp to cloudchart.jsp. The main change is in the line d3.csv. We change it to accept JSON data instead, and therefore it is changed to d3.json. The parameter of the function is no longer the static data.csv. We make it dynamic by the RESTful web service path and pass the symbol parameter from the form chart attribute. In header.jsp, add a menu item for the chart. Restart the application. Click on Chart. Input 0001.hk at the symbol. Click on Show Chart. Wow, the candlestick chart of 0001.hk is shown. On top of that is the Ichimoku Cloud technical indicator. So we can now show charts of different symbols on the web. In the next video, we'll look at member registration and flash messages. Welcome to the last video of this section, Registration and Flash Messages. In the previous video, we used JSON to pass stock data to tekken.js to plot some beautiful charts. In this video, we're going to build the membership service. We'll modify the member registration form to save the new member data into Cassandra. We'll also make use of flash messages to return the registration status to the view. Open registercontroller.java. Previously, we completed the post-register form method. It does nothing but return to the home page only. Now we'll modify it to save the registration data into Cassandra. Create a new POJO called member. This POJO maps to the member table and is so annotated. The attributes just mirror those in the member table, namely username, email, full name, password, and active. Generate the toString, constructors, hash code, and equals methods. Next, create the repository interface for member. Name it member repository. For the time being, we'll just use the default implementation. Let's move on to create the service for the member registration. The class is named memberService and annotated with @service. Make member repository auto-wired like this. Add a method, registerNewMember, which accepts register form as a parameter. Create a local member variable. Map its attributes with the corresponding fields in the register form. Lastly, we call the save method of the member repository to store the registration into Cassandra. Of course, we can add some validation logic here, for example, to check for duplicated username and so on. But we'll skip that at the moment. Go back to Register Controller. In the post-register-form method, we may add memberservice.registerNewMember register form. Make the member service auto-wired. Alright, test run the application. Click on Register, input some test data. Click on the Register button. It just returns to the home page. Let's check the table in Cassandra to verify the result. Great, the test data is here. But it's a little odd that we haven't got any message for a successful registration. The user experience would be better if we're notified of the result. This interaction can be easily done in Spring Web MVC by flash messages. In Register Controller, we add an extra parameter called Redirect Attributes after the binding result. Redirect Attributes is a specialization of the model interface that controllers can use to select attributes for a redirect scenario. It also provides a way to add flash attributes. Add redirectattributes.addFlashAttribute here. Call it flash type and set it to success. Add another flash attribute, flash message. It says registration successful. And change the return to redirect/home. Now we need to modify header.jsp to display the flash message. After the navigation bar, add an if statement to check if there is any flash message. If not empty, we use Bootstrap Alert CSS to display the flash message with appropriate style. The technique is to append the flash type attribute to the Alert CSS class so that we get the desired color. Add a close button for the alert box, then the actual flash message. Restart the application. Again, we'll register another test member. Click on Register. See? We have the registration successful message shown beneath the menu bar, nice and beautiful. Check the backend table again. The registration data is saved. Awesome. That's a wrap for this section. In this section, we continued working on the Cassandra WebTrader web application. We learned about how to use message source and locales to internationalize our application. We also connected the application to Cassandra and made our applications data aware. We then implemented a scheduled job to collect and decode the historical prices supplied by Yahoo Finance. Those historical prices were converted into a JSON format by a RESTful web service to render stock charts at the front end. Finally, we modified the member registration to save data in Cassandra and enhanced the user experience by appropriate flash message. In the next section, we'll finish Cassandra WebTrader as an end-to-end web application. Join me there. Welcome to the 8th section of the Mastering Cassandra video course. In the previous section, we further polished the user interfaces and functions, and made dynamic stock charts with real data feed. In this section, we'll add in some more advanced and cool features to Cassandra WebTrader application. We're going to further enrich the functions and features of the application. We'll secure the application with login and user authentication. We'll also program the logic for scanning trading signals. The trading signals found will be stored in Cassandra, which can be inquired online. We'll also make a scheduled job to send out daily trading signals through email. Lastly, we'll add in user roles and authorization supports. Okay, let's begin from user login and authentication. In this video, we'll use Spring Security to protect some of the application functions that require user login. We'll then learn how to use Java-config and taglibs to secure the application. Spring Security supports authentication and authorization. We'll first enable our members to log on to the application by username and password. Add in the Spring Boot Security Starter Maven dependency, as shown here. Also, we need Spring Security taglibs. Then, create a Java-config class called WebSecurityConfig. Annotate it with @configuration @enableWebMVCSecurity. And extend it from WebSecurityConfigurer-adapter. Since we need to access member data to check the correct username and password pair, we need the Spring Security's provided User Details service to do so. Then we write the URL patterns in the configure method. It does two things. First, we use Apache Ant patterns to denote the URL patterns that are accessible for anonymous users. For example, the home, error, member registration, public, and so on. The second thing is to configure the login and logout page to be used. In our application, we use a simple HTML form login page. Then we override the configure method to link up to user service for authentication logic to auth-manager-builder.user-details-service. The so-called user service interface should be implemented by our member service, so open member service class. Modify it to implement user details service. Add the unimplemented methods. The one that we need to do is load user by username method. Change the parameter name to username. The logic here is very straightforward. We try to retrieve the member data by the given username through the member repository interface. If the username is not found, simply throw a username not found exception. Otherwise, we return a new instance of userdetails IMPL class. The find by username method hasn't been coded yet, so let's do it now. Add the @query to look up the member table for that username. The last missing piece is the userdetails IMPL class. Create the class. It should implement the userdetails interface. Add the unimplemented methods. Add the member attribute and set it up in the constructor. Then the getAuthorities method. For the time being, we assume all authenticated users are granted with role_user authority. Next, set the getPassword method to return the password of the member. Then the getUsername method, and so on. Go back to member service. Correct the error by importing the userdetails IMPL class we've just created. Next, we need to create the login form. To speed up the task, we don't create that from scratch. Do login.jsp by copying register.jsp. Modify the page title. Add an error block to show in case of any errors, such as invalid username and/or password. Add another block to show if the user has just been logged out. Then fix the username and password controls and change the caption of the submit button to login. Then use webConfig class to add the view controllers to register the view name to the corresponding URL. Next, modify header.jsp to show login and logout links. And we want to make the menu bar dynamic to show different options to an anonymous user or an authenticated user. It requires Spring Security taglib added at the top. For an anonymous user, we want her to be able to access the home, login, and registration. On the other hand, authenticated user can access logout, chart, watch list, and so on. So we use the authorized tag to do that. Let's run and test the application. Now we see that the menu bar shows less options for anonymous users. Click Login. Enter user0001 and his password 123456. Click on the Login button. Wow, the menu bar has changed to show the member-only options. The chart shows up. Other links also work like a charm. Finally, click on Log Out. Well, we're brought back to the login page with the logged out message displayed. So, we enabled login and authentication to Cassandra Web Trader. Next, we'll look at the algorithm of finding a trading signal. Welcome to the second video of this section on trading signal. In the previous video, we added login and user authentication to the application. In this video, we'll program one simple trading signal called bullish engulfing to scan our stock data in Cassandra. We'll also learn about how to make use of an open-source technical analysis library named TALib to calculate a simple moving average that acts as an additional filter to the signal. And we'll verify the implementation of the trading signal visually with the corresponding stock chart on an external website. Bullish engulfing is best illustrated by candlesticks. A candlestick is composed of 4 prices: open, high, low, and close. If open is greater than close, the candlestick is called a black candle, meaning a down price. Conversely, it's a white candle for an up price. The logic of bullish engulfing is simply a white candle fully engulfed the previous black candle. Mathematically, the logic is shown here. Apart from that, we use a simple moving average, SMA, as an additional signal filter. As the SMA is required for our trading signal, we'll use a very handy open source library called TALib. Open pom.xml. Add the TALib Maven dependency as shown. Then we create a new service class named Scanner Service. Annotate it with @service. We target to scan for trading signal over the latest 1,000 days, so we set a constant, days to scan, to be 1,000. Add a private attribute TALib core to call TALib. Obviously, we need to access quote repository to get the stored data. Then instantiate TALib core in the constructor. Create a method called bullish engulfing with a list of quote objects as its parameter. Declare the signal name as bullish engulfing and the period of SMA to be 12. Because TALib uses arrays of primitive type double for parameter passing, we create two arrays to hold the close prices and the calculated SMA 12 values. The list of quotes to be retrieved from Cassandra is sorted in descending order, so we use collections.reverse method to sort the quotes into ascending order instead. Then use a for loop to fill up the close price array. Also, declare two local variables of integer type for TALib's calculation. We call the SMA method of TALib core to return an array of SMA 12 values. If the call is successful, we start our scanning in this for loop. We make two variables for the quotes of today and yesterday to look for bullish engulfing signal. The logic is here, and we refine it by checking if the SMA 12 is trending up. If one is found, we show the details in the log console. We also write a helper function, convertDecimal, in common util, to convert the numbers into two decimal places. Finally, we create a scan method, which accepts a symbol parameter to handle the retrieval of stock data and call bullish engulfing method. Now we've finished Scanner Service, and should proceed to add this trading signal scan function right after the collection of the stock data from Yahoo Finance. Open up Yahoo Feed Job. Add Scanner Service here. Then, inside the watchlist for loop, add the call to scannerservice.scan method. Alright, let's run the application. Here it goes. We collected the stock data and scanned for bullish engulfing signal. Over the last 1,000 days, there are more than 10 signals. Let's check the latest one with Yahoo Finance's stock chart. Switch to Firefox and go to Yahoo Finance. Enter 0001.hk. Click on Interactive here. Make it a bar chart, add an SMA 12 to the chart. Select YTD for showing up the data in this year. You see here, it shows a bullish engulfing pattern, with the SMA trending up, so our scanner functions well. Next, we'll look at the online function for the inquiry of trading signal history of a stock. Welcome to the third video of Section 8, Signal History. In the previous video, we designed a very rudimentary trading signal for our application. In this video, we'll apply the design by query technique to create two Cassandra tables of similar structure to meet different requirements. Accordingly, we'll create the POJOs and the logic of saving them into the database. And we'll build an online inquiry function to illustrate the use of one of the tables. In the last video, we programmed the algorithm for scanning trading signals, but we haven't stored the signal information into our database. The trading signals can be used for different purposes. Firstly, we want to make an online inquiry function for a user to look for the trading signal history of a particular stock, which means we should design a table for querying the signal history by stock symbol. Second, we want to find out the signals by each day, so we should design another table for querying the signal history by date. As such, we have two tables for two queries. We create the signal history table for the first purpose and the signal per day table for the latter. We already have the signal history table created earlier. Now we only need to create the signal per day table. With new tables created, the typical workflow involves the creation of the corresponding domain classes. First, the signal history class. Second, the signal per day table. They're pretty straightforward, and we won't spend time on their explanation. Also, we create the signal history repository interface and the signal per day repository interface for the query and manipulation of the data. Then we'll modify the scanner service class to include the logic of saving trading signals into these two tables. Open up the scanner service class. Add two private auto-wired attributes for signal history repository and signal per day repository, respectively. Then, inside the bullish engulfing method, we add another date format to convert date to string. We add the creation of the POJOs and call the repositories to save them into the Cassandra database. Nothing too difficult up to now, right? Next, we'll create the online inquiry function. Create a new JSP file called signalhistory.jsp. It's very similar to watchlist.jsp. Put an HTML form at the top of the page for a user to input a stock symbol. The post request should return the signal date, signal price, and signal name from the signal history table. We use a for loop to iterate the signal history DTO and print the columns as shown. The signal history online function should be shown on the menu bar, and we modify header.jsp to do so. The view is complete, and we now proceed to work on the controller. Create the signal history controller class. Add @controller and @request mapping annotations. Add a private auto-wired attribute to link up signal history repository. Then create the show signal history page method to handle the GET requests. We reuse the chart DTO as the model for convenience. For post requests, we create another method called process signal history page to get the stock symbol and pass it to signal history repository to retrieve the trading signal history. Then the list of trading signals will be passed to the view signalhistory.jsp. Finally, we implement the find by symbol method of the signal history repository interface with the CQL statement as shown here. That's it. Let's run the app and test the online function. Log in as user 0001. Click on signal history. Input 0001.hk in the symbol and click on the Get button. The trading signals of the stock are listed out in a table. Next, we'll continue to use the second table to facilitate our scheduled trading signal email alert service. Welcome to the fourth video of this section on email alert. In the previous video, we made a user interface for the inquiry of trading signal history of a stock. In this video, we'll use Spring integration to set up an outbound email channel for sending out trading signal daily alert emails. We'll use the signal per day table to get the trading signals. And we'll schedule the mentioned tasks as a job running in the background. Well, the first thing required for Spring integration is to add its Maven dependency to our pom.xml. Here we use Spring Boot Starter integration to simplify the configuration. Next, create a configuration class named Integration Config to configure the outbound messaging channel. Add the annotations @configuration, @integration component scan, and @enable integration. In our example, it's a local direct channel with a name Notify Channel. Then create a service class for the business of producing alert emails. It's called Daily Alert Service. Annotate it with @service. Since we'll access the signal per day table to find out the trading signals on a particular day, we need signal per day repository. The major method is named Generate Trading Signal Alert. It should be run to generate an alert email of today, but for testing purposes, we just set it to a testing date. It then calls the private Generate Alert Body method to write up the email message. This method does three things. One is to get the trading signals on a day, and the second is to format the email message body, and the last thing is to submit the composed message body to the Notify channel. The benefit of using a messaging channel is that if we want to enhance our application to send out alerts through Twitter as well, for example, we don't need to modify the logic here. That new Twitter service consumer will not be tightly coupled with this class, and hence we achieve an architecture of greater flexibility and expandability. If no trading signal is found, we just say that in the email. Otherwise, we iterate through the signals and list them out. We complete the find by date method with the correct CQL statement as shown. The email message body is a list of rows containing the symbol, close price, and the trading signal name. Last, we come up with a message of string type to add to the email message body as its payload, and submit it to the notify channel. Of course, we need to auto-wire the notify channel as shown. We want to name this message channel notify channel, and so we use @resource instead of @autowired. We want to schedule to send out email alerts on a regular basis, and so we create a daily alert job class to do that. The skeleton of the class is not something new to us, and we won't repeat the explanation here. The method to be scheduled is run daily alert service. It's configured to run according to a cron expression, which is read from the scheduler.properties file. Which means we need to add the properties in the properties file. The run daily alert service property indicates whether the job should be run. And the alert.send property is the cron expression. The cron expression means to run the job at 23:23 each day, as an example. We complete the scheduled job logic. If the job is to be run, the daily alert service is called to generate email alert. To consume the Spring integration messages, we need to modify mail service to be a message consumer. The @service activator annotation does the magic, and the input channel qualifier is to specify the messaging channel that it's connected to. We add a string parameter body to collect the message payload. Also, we want to put the hard-coded values into a properties file called mail.properties. Make mail service read the mail.properties file by adding the @property_source annotation to the class. The content of mail.properties is shown here. Finally, we need to change the mail controller, as previously we used it to test the mail service. We just set a dummy body for it. For testing purposes, let's modify the cron expression to trigger the job to run immediately. Okay, let's test run the app. After the scheduled time is reached, the email alert is sent out accordingly. Check the mailbox, it's there. So, the trading signal daily alert email can be scheduled to send out successfully. In the next video, we'll refine our application with user roles and authorization support. Welcome to the last video of Section 8, User Role and Authorization. In the previous video, we saw how to use background scheduler job to send out email alerts. In this video, we're going to enable role-based authorization in our application. We'll modify the member table to add a field to indicate the role of the user. We'll make an online inquiry function for administrator to list out the member information. And we'll demonstrate how to use Spring security tags to render dynamic menus based on user role. We alter the member table to have a field called role. This field indicates the role of the member. We created registered members earlier. Among them, we want user 0001 to be a normal user, carrying the role_user role, and user 0002 and con to be administrators, with the role_admin role. They'll be used for testing later. Here we just use 2 roles, and of course we can have many more to suit our needs. Add the role attribute to the member domain class. Regenerate the constructor, toString, getters and setters, and so on. Next, add the default role, role_user, to each new member. The web security config should also be set. We group the administrator functions in the URL pattern /admin/**, and therefore we add in a new ant matchers to check for the role_admin role. Note that we may use a short form admin instead of role_admin. Spring Security takes care of that. Create a JSP page called memberinquiry.jsp. Give it a title, Member Inquiry. Make up a table with columns username, email, full name, password, and role. Then a for loop to show the rows one by one. With Spring Security tags, we embrace the administrator functions and will be granted access if we have the role_admin role. Also, remark the drop-down menu below. We need to change the hard-coded role_user role in UserDetailsIMPL class to the user role read from the member table. Create a controller for the Member Inquiry page. Name it Member Inquiry Controller. It's simple and just retrieves all member information from Cassandra and passes it to memberinquiry.jsp for showing. Test run the application. We log on to the application as user 0002. User 0002 carries the role_admin role. As an administrator, we can access the restricted functions like watchlist and member inquiry. Let's log out and log in as user 0001 to be a normal user. We see that the menu for a user of role_user doesn't include access to the administrator functions. In this section, we used Spring Security to provide user login and authentication functions. We implemented a simple stock trading signal called bullish engulfing to look for trading opportunities. We also applied the design by query technique to save data to two similar tables, signal history and signal per day. Signal history is used for an online function, while signal per day is for a background job that sends out email alerts on a regular basis. Finally, we implemented a role-based authorization mechanism for users of different roles. In the next section, we'll finish Cassandra WebTrader and make it ready to be deployed to production. Welcome to Section 9 of Mastering Cassandra video course, Deploying to Production. In the previous section, we enhanced the application with some important functions, such as user login, authentication and authorization, and trading signal algorithm. In this section, we'll finish the Cassandra WebTrader application and get it ready for production deployment. We're going to enhance the trading signal email alert to send to active subscribers. We'll also add a forgot password retrieval function. We'll then refine and clean up the application and add in Spring Boot Actuator, which provides some very nice and useful production features. Lastly, we'll introduce the various deployment options provided by Spring Boot and actually deploy the standalone WAR file for Apache Tomcat. So let's begin to modify the email alert function. In this video, we'll improve the business logic of sending trading signal email alert function to active members. We'll add a secondary index on the member table to select active members. Then we'll change the related business logic accordingly and test the modified function. We add a field called active to the member table. The new structure of the member table is as shown here. To come up with a query for active members, we may add a secondary index on the member table. We'll create a secondary index on the active field, which is either Y, meaning an active member, or N otherwise, so it fits the use of a secondary index. Select all members. Let's add a new user, user 0003 in CQLSH. Let's change the active field of user 0001 to Y, such that they can receive the email alert, and N for user 0002 and Con. Now, with the secondary index just created, we can select all from member where active equals to Y. Great, it's done. Go back to STS. Open up the member repository interface. Add a new function, findByActive, to return a list of active members as shown. We may now modify the Daily Alert Service class. Auto-wire the member repository. Inside the Generate Trading Signal Alert function, we need to retrieve the active members through the findByActive method of the member repository, and send an email to the members one by one in the for loop. As such, the Generate Alert Body function is modified to accept an extra email parameter. Since we use a string as the message payload for Spring integration, we do a little trick to add the member email to the head of the string, delimited by a pipe character, then the message body. It keeps the change to a minimum. The counterpart Mail Service class also needs some touch-up. The Send Mail Alert function is changed to handle the added email address. We simply split the body parameter by the pipe character, so that the first part is the email address and the second part is the message body. Then replace the hard-coded email address in the mail properties file to this passed-in email, and pass the message body to the setText method. Alright, the code modification is complete. Run the application. Wait for a few seconds. Well, we see from the console log that two email alerts were sent to user 0001 and user 0003 respectively. So the application behaves as we expected. Great! Next, we'll add in a forgot password retrieval function. Welcome to the second video of Section 9, Retrieving the Forgotten Password. In the last video, we used Spring integration to send an email alert to the members of Trading Signals. In this video, we'll supplement the application with a forgot password retrieval function. We'll create its MVC components, and we'll modify the mail service class as well. Because the forgot password function is for registered members only, we'll add its logic to the member service class. When a member has forgotten the login password, we'll look up their email address by the given username and send the password to it. So let's add a new function named generateForgotPasswordBody to get the email address by the username, and then compose the forgot password email message body, and finally call the mail service to send the email. Add an auto-wired variable pointing to the mail service class. Open up the mail service class. Add the sendGenericMail function as shown. It's very similar to the sendMailAlert function above. It's simple and straightforward. Indeed, we may refactor the sendMailAlert function as well, but let's skip it and get back to that later. Then for the MVC components, we create a DTO called username for form parameter passing. Generate the constructors, toString, and so on. Then we create the forgot password controller class. First, the method to process the GET request. Basically, it'll pass a form parameter for the username to a view called forgot password as well. Then the method to handle the POST request. If no error is found, it calls the generateForgotPasswordBody function of the member service class to send an email. We also used redirect attributes to pass the flash message back to the home page. Now the view. Create a new JSP called forgotpassword.jsp. Create a form with an input box for the model attribute username for POST requests. That's all. Then we need to allow not logged in members to access the forgot password function. We open up the Web Security Config class to add the forgot password URL for them like this. Finally, add that URL to the header.jsp. Put it under the section for anonymous users. Alright, it's time for testing. Run as a Spring Boot app. The forgot password option is shown on the top menu bar. Click on that. Enter a username and click the blue button below it. It's processing. We are then redirected to the home page with the message that says the forgot password email is sent, please check. It works as expected, excellent. Let's also double check the console log. Here we see that the password was retrieved for the user 0001, and it was sent to the registered email address. That's cool, we achieved what we wanted. Next, we'll refine and clean up the application to get it ready for production deployment. Welcome to the third video of this section, Refine and Clean Up. Previously, we added a forgot password function. In this video, we'll remove and clean up some test classes and pages that we created for prototyping purposes. We'll also add in meaningful description on the web pages. And finally, we'll change the URLs of the function to be context path sensitive. The first thing to do is remove the trading signal controller class. Right-click on that and select Delete. Click on OK. Then open up header.jsp. Delete the line that provides access to the trading signal, so we remove it from the user interface. Also remove the unused drop-down menu and navigator option on the right-hand side of the top menu bar. OK for the menu. Delete tradingsignal.jsp. Right-click, delete, and click on OK. As we would like to package the application as a production-ready web archive that can be run in a servlet container or web application server, we need to make our absolute URLs to be relative URLs in the JSP pages. Let's walk through all JSP pages and prefix the absolute URLs with the JXP expression string bracket page context dot request dot context path close bracket. It makes the URLs context path sensitive and flexible, as it does not constrain the WAR file to be deployed to the root context path. Each absolute path must be prefixed with the context path expression. We also need to add the context path to the static files, for example JavaScript, CSS, fonts, and so on. The JSON URL also needs the context path, no exception. All URLs are done. Let's test run the app to check again. Click on Home, OK. Click on Login. Login as user 0001, who's a typical user. Good, it shows the history as expected. Click on Chart. Enter 0001.hk as the symbol. Click on the button. The chart is shown. Great. Click on Logout. It's redirected to the login page again. Click on Register. Now try switching the language to Spanish. No problem. Then click on Forgot Password. It also works as expected. Excellent. Then log in as user 0002, who has an administrator role. We can test the watchlist function now. The symbols in the default watchlist are shown as expected. How about the member inquiry function? Well, it's fine as well. So the addition of the context path works perfectly, even though the URLs here do not have context path. But it's important to make the application context path sensitive, since we usually deploy the application to a context in an application server. Next, we'll continue to add some administrative functions provided by Spring Boot Actuator for production-ready deployment. Welcome to the fourth video of Section 9, Spring Boot Actuator. In the last video, we refined and cleaned up the application to make it ready for deployment. In this video, we'll introduce Spring Boot Actuator, which provides some great production-ready functions. We'll set up the Cassandra WebTrader application to enable Spring Boot Actuator. And we'll then test run some of its functions. If we go to the official Spring Boot website and read the Spring Boot reference guide, Spring Boot Actuator is documented in Part 5. Basically, Spring Boot Actuator provides some additional out-of-the-box, production-ready monitoring and trace features, so that we don't need to write our own or directly deal with Java Management Extension JMX. We can manage and monitor our application using the so-called HTTP endpoints, with JMX if we like, or remote shells like SSH or Telnet. The table here lists out all the default endpoints that come out of the box, and briefly describes what they do. Some of the endpoints are marked as sensitive, which means if Spring Security is added to the application, as we do, basic authentication will be used to protect all the sensitive endpoints exposed over HTTP by default. We'll examine some of them now. Spring Boot Actuator is very easy to set up. We just need to add the Spring Boot Starter Actuator module dependency to the pom.xml file, and it'll work automatically. Copy and paste the Spring Boot Starter Actuator module dependency and save the file. When the Maven updates are finished, run as a Spring Boot app. Let's try the endpoint autoconfig. The application redirects us to the login page because the autoconfig endpoint is a sensitive one. After login, Spring Boot Actuator replies a JSON response, which is very difficult to comprehend. We can install some handy browser add-ons to present the JSON responses better. As Firefox is used, we may install the JSON View add-on. Click on the green Add to Firefox button and wait for the download to finish. Click on the Install button. Refresh the page. Wow, it's much easier to read now. Try the beans endpoint. It says that there are many singleton beans, such as the main class, CWT application, Yahoo feed service, and so on. Then the health endpoint. Just a very compact response saying that the status of the application is up and some metrics on the disk usage. Other internal metrics can be found at the metrics endpoint. Here we can check the memory metrics, for instance heap size, GC statistics, and so on. Finally, we may visit the trace endpoint to trace back each pair of request-response produced in the past. Fine-grained control on enabling or disabling of a specific endpoint can be done through setting Spring properties in the application.properties file. Or we may write our own custom health indicators by implementing the health indicator interface. So it's very versatile and can meet any unique needs. In the next video, we'll explore different deployment options for a Spring Boot application and demonstrate how to do them. Welcome to the last video of this section, Deploy Spring Boot Application. In the last video, we used Spring Boot Actuator to embed production monitoring and administration functions to our application. In this video, we're going to deploy the Cassandra WebTrader application to production environment. We'll consider different deployment options provided by Spring Boot and make necessary modifications based on those options. And we'll also discuss how to avoid application crash if we want to deploy the application to Apache Tomcat. If we look back at how we developed the application so far, it's obvious that we don't test the application in a standalone web container or application server. The reason is because Spring Boot allows us to embed a servlet engine in the application, such that the application can run by itself. In other words, the application can be packaged as a jar file that contains everything required to run as a standalone application. Before we demonstrate how to do it, let's open up the pom.xml file and change the start class tag to the com.cassandrawebtrader.cwt application class. This indicates the entry point of the application. We'll use Maven to package the application as a jar file. Select CWT in the Package Explorer window. Right-click and select Run as Maven build. We set the goals to Clean Compile Package. Click on the Apply button and the Run button. Maven starts building the package. When finished, a jar file named cwt-0.0.1-snapshot.jar is created in the target subdirectory. Type in java-jar target/cwt-0.0.1-snapshot.jar. See, Spring Boot starts to run the application and dumps a bunch of messages on the console. Wait a few seconds for the application to start up. We may then switch back to Firefox and test the application in the same way. The application works exactly the same and the URLs are the same. Remember that the application runs on the embedded Tomcat servlet engine. The messages are shown in the console as well. Press Ctrl-C to stop the application. A more traditional way of deploying an app to production is to package a WAR file for an external web container or application server. If we want to run the application in the external Tomcat web container, we need to package the app as a web archive or WAR file. So we open up pom.xml and change the packaging tag to WAR instead of jar. One problem typically encountered is Tomcat's class loading issue. As Tomcat has its own set of jar libraries, we need to exclude them from our application. Otherwise, we'll be very likely to crash our app in Tomcat. Hence, we explicitly exclude the Tomcat module dependency Spring Boot Starter Tomcat from the Spring Boot Starter Web module. By doing that, the jar libraries potentially conflicting those in Tomcat would be excluded in the WAR file, thus avoiding application crash. There is also a known problem that it requires an embedded database, be it H2, HSQL, or Derby, when running as a WAR file. So we add in the H2 database module here as a workaround, although we never use it. Then we change the build.finalName to CWT instead of the cumbersome default name CWT-0.0.1-snapshot. We also disabled database refactoring done by Liquibase in the application.properties file. Note that Liquibase is a database restoring function enabled by default. The deployable WAR file requires a Spring Boot Servlet initializer subclass with its configure method overridden. It makes use of Spring Framework's Servlet 3.0 support and allows us to configure the application when it's launched by the servlet container. So we modify the CWT application main class to extend Spring Boot Servlet initializer and override the configure method accordingly. That's all for the code modifications. One final thing to do is add the JSP standard tag library, JSTL, to Tomcat. It's not bundled in Tomcat by default. For us, version 1.2 is fine. Therefore, we copy the JSTL-1.2.jar file from our Maven repository to the Tomcat lib directory. Okay, now we may manually deploy the WAR file to the Tomcat server. We simply copy the WAR file to the web apps directory. Start up Tomcat. We see that cwt.war is extracted. Let's test the app. The login page is shown, but look carefully at the address bar. The URL now has the context path CWT. Play around in the app and no problem is found. Thus, we successfully repackaged the app as a WAR file and deployed it to a production Tomcat server. In this section, we added some more business functions to Cassandra WebTrader. We also cleaned up and prepared the application, ready for production deployment. In addition, we enabled Spring Boot Actuator so that we can easily monitor and manage our app. Finally, we illustrated the different deployment options provided by Spring Boot and demonstrated how to do it one by one. In the next section, we'll quickly review what we've learned in this course and provide some reference materials that would be useful. Welcome to the final section of the Mastering Cassandra video course. In this section, we'll come to the conclusion of this course. Up through the last section, we finished our Cassandra WebTrader application from birth to deployment. We're going to wrap up the whole course and introduce some useful reference materials. Firstly, let's revisit the course. In this video, we'll review the software development process that's been used to design and build Cassandra WebTrader. We'll then revisit what we've learned and highlight the important points. We started our journey at the introduction of the modern Java web application development technologies. We followed the contemporary multi-tiered application architecture to select the components for each of the tiers to design our example application, Cassandra WebTrader. We used Cassandra as the data store sitting at the bottom of the architecture, and extensively adopted the Spring framework and its sub-projects to construct the business tier. On the client tier, we use HTML5, CSS3, JSP, Bootstrap, and D3.js to make up a stunning, fully responsive web user interface. We then installed, set up, and configured our development toolbox, and got ourselves familiar with their usage by making up small sample programs. Then we crafted out a high-level design of Cassandra WebTrader by completing the typical software development tasks. For example, collecting and analyzing user requirements, designing the user functions and grouping them into logical packages, designing the data model and the class model, and lastly, producing some screen prototypes. Next, we concentrated on the Spring Framework components by writing small programs to get ourselves up to speed. As the main objective of this course was to introduce how to use Cassandra in Java web application, we dived deep into Spring Data Cassandra with many examples. From sections 6 to 9, we did the actual implementation of Cassandra WebTrader, based on the high-level design developed in the early sections. Finally, we discussed how to deploy the Spring Boot-based Cassandra WebTrader to actually run in Apache Tomcat. Here are the important knowledge and skills that we now should have mastered in this course. We should now understand how to use Spring Framework and its sub-projects for fast Java web application development. How Spring Data Cassandra can be used. For a large-scale application system, Spring integration should be the right messaging. Regarding modern front-end web user interfaces, Bootstrap and other popular JavaScript frameworks or libraries should be integrated to the back-end Java web application. We've quickly gone through our approach of developing Cassandra WebTrader and distilled the essences that should be mastered in this course. Next, we'll look at some useful reference materials on the internet and in books. Welcome to video 10.2, the final video of Mastering Cassandra. Further references. In this video, we'll quickly go through a list of websites where we've used their products or solutions in this course. We'll also find some useful books and courses. So this video is a one-stop shop for further references. The number one important site to Cassandra, in my opinion, is DataStax. It provides commercial support and product offerings based on Cassandra, and publishes up-to-date documentation, coding tips, tutorials, and examples for free. Whenever we come across a problem, go there and look around first. Its sister website, Planet Cassandra, also provides a large amount of information related to Cassandra. Its focus is put on real-life use cases. We may find many use cases in the big names, a must-read for Cassandra lovers. It's also a central place for the Cassandra community. It organizes meetup groups all over the world for the community to collaborate. If you want to chip into Cassandra, the official Cassandra website in the Apache Software Foundation is the place to go. You can contribute to test or enhance the source code with many other developers and get a sneak peek into the latest features. At the heart of our Java project, we use the core Spring framework and its sub-projects to simplify and speed up the development process. We also use Spring Boot, Spring Data Cassandra, Spring Security, and Spring Integration to provide enterprise-class support to Cassandra WebTrader. However, the whole Spring family is so large and complex that we have to spend time to get familiar with it. Apache Tomcat is a lightweight web container or servlet container to run Java web applications. It now comes to version 8 when this course was recorded, and we've deployed Cassandra WebTrader to run on it. Also from Apache Software Foundation, Maven is used to manage module dependency, packaging, and build process automation. With the crazy proliferation of mobile devices, a non-responsive application would just bring an upset experience to the users. Bootstrap is a quick and good solution to make a web application responsive. Its website contains all the required information for a developer to use it immediately. jQuery is common and backs up Bootstrap. Apart from that, it also offers a wealthy set of UI components and frameworks that a stunning web or mobile application cannot live without. D3.js is one very popular JavaScript library dedicated for data visualization. It's free and powerful, although in my opinion, it takes a bit of a steeper learning curve. We used Tekin.js, which is based on D3.js, to render beautiful technical charts. In Cassandra WebTrader, we just used some of its basic features. There could be a lot more to try here. For example, we could add interactivity to our charts backed by D3.js. Maybe we could allow the member to add in a bunch of technical indicators to the charts, just to name an example. For technical analysis algorithms, instead of writing our own unique indicators, we may make use of open source TA-lib, which provides a great deal of commonly used indicators. It supports many different kinds of programming languages, such as Java, C#, Python, Perl, and so on. Of course, Pact Publishing has been releasing many books on Cassandra. You'll find the latest updates on their website at www.pactpub.com. For example, type in Cassandra in the search box. Many items are shown, among which 2 are authored by me: a video course, Cassandra Administration, and a book, Cassandra Data Modeling and Analysis, respectively. I also suggest you reading a very good book, Real-Time Analytics with Storm and Cassandra. Another Cassandra video course that's authored by me is Rapid Cassandra. I do recommend you watching it as well, since it's the precursor of this course. We've had a good time building a working software from scratch. I really hope this video course helped you understand how Cassandra can be used in real-life systems. I enjoyed making a video course like this, and hope you enjoyed it as much as I did. Finally, thank you for watching.